Hi friends, welcome back. Here in this lecture we're going to start our programming with Java. So let's start. Before we have to write our program, the Java program on the notepad or any text editor, we have to first ensure few things. There are few requirements to execute our Java programs. We need to have installed versions of JDK, Java Development Kit, for both the Enterprise Edition and Standard Edition on our PC if we don't have already installed it. You can find the JDK and install it online, and we have the installation section where you could learn the steps that are required for installation of JDK if you have any doubt. Then you need to set the path variable for this JDK that could be routed back on the command line, and you could verify whether it is installed or not. Then after we are done with the setting of path variable and installation of JDK or JRE, now we have to write our Java programs. After we have written the program, we have to save it with the .java extension and compile and run this Java program. So here in this lecture, we are going to write a Java program, simple hello world program example. The first example for any beginner, and we need to compile it and run the program. So here is a simple program. Suppose we want to print a string or set of character or message on the screen, say hello Java or hello world, hi, namaste. We can print it by writing this simple syntax. A Java syntax consists of system.out.println, which is used to display the output on the screen, which is covered under the main function. Note the yellow color main. Public static void is the syntax for this writing this thing. It is a public method being static, and it returns no value, so it is displaying the void. It contains the arguments that are defined in the string. Don't need to understand everything, just these above two lines. A class name, a class syntax, we need to define everything in a class. When we are writing any program in the Java environment, we need to write a class, define a class, and the function which is understood by the compiler is the main function. Suppose when your program get very long or complicated, there will be use of multiple functions that we are going to learn. So the program compiler starts the execution from the main function. So this is the main function, and we need to provide everything in the main. So above two lines, the class simple, the public static void main, we need to write these things in all our programs from now onwards. This new line is the system.out.println would help our compiler print a particular string, that is hello Java, on the screen. And we need to provide the curly braces for opening and closing the arguments. After we are done with this Java file, we need to save this file with the file name.java extension format. The file name would be the same as the class name. So class name was simple. So we will be interested in saving this file with a simple .java extension. So when we are done with saving this file, we can move with a command prompt and open a command prompt and just write a simple program, simple command, Java C, that means Java compile this Java program and provide the name of the file. If the file is located in the same directory, it will execute that thing. And if it is located in another directory, uh, you need to provide a path name. Then after the compilation has been done, it will be generating a byte code or class file. To execute those class files and display the output on the screen, we need to write a Java and a file name without extension. So it will execute this thing. We are going to do this thing practically in practical sessions. So this was a theoretical background. If you have any doubt, you could ask this thing. So what happens at the compile time when we compile a thing? Here's our Java program. say any file simple.java, we compile it using a compiler, it will generate the bytecode a.class file. So our Java C command is the compiler, and after we have generated the bytecode or the class file, it will be executed using the Java command. So this was a basic simple hello world program. Uh, Try building your own programs. You can display multiple strings on the screen with the separation of different lines or without any separation of line. We will be learning more in the coming videos. Till then, keep learning and keep moving ahead. Hello and welcome back. Here in this lecture, we're going to learn about the difference between Java Standard Edition and Java Enterprise Edition. So let's start. Java Standard Edition and Enterprise Editions are the core functionalities or the key units of a Java ecosystem or Java programming language. When you're trying to learn the Java programming and use it in the real world, there could be various scenarios, and for those different scenarios, you have to choose whether you are going to starting your journey with Java Standard Edition or Enterprise Edition. If you are going to develop certain things that are based on desktop softwares, say a video player or like a VLC or a media player or anything like that, you would be using Java Standard Edition or any client applications. And when you are going to develop your website or server side, implement your server side logic, create a certain kind of exchange server, email server, or a payment gateway or things like that, you will be using Java Enterprise Edition. So here in this lecture, we are getting into depth about the difference between the two, just for the beginners who have a little glimpse of these two things. So Java Standard Edition is the core Java programming platform. Because it is the core, it is the basic thing of the Java programming, just like the core of Earth is things like whenever you are standing on the Earth, it is based on its code. Similarly, the standard edition, the keys are like string library, the data files, and things like that that are basic. It would be used in enterprise editions as well, like Java.lang library, language, Java input output, Java math, Java.net, Java the utils. These are all the libraries and the APIs that any Java programmer should learn. So whether you are trying to build your desktop applications or be moved with server editions, you have to start your journey with the standard edition. So when you are moving ahead with the server implementation, you have to learn the enterprise edition, the Java EE. Uh, it differs from the standard library by adding more libraries, APIs, or functionalities that would help you to deploy the fault-tolerant, distributed, and multi-tier, the client server. These are the two-tier architecture, the client server and the database server, the three-tier, and even multi-tier, the infinite tier or multi-dimensional Java software you could implement with Enterprise Edition. It is based largely on modular components running on different kinds of application or web servers, like Apache Tomcat or different things like that. So, what is the with this diagram? We have a simple scenario where we can distinguish between the SE or the Enterprise Edition. With the Standard Edition, we get management Windows Archive file WAR, the connector jar Java archive file, and the SE rule sessions, the persistence of database and file, which is composed in the SE. And similarly, with Enterprise Edition, we have the EAR, the jar, the persistence. Similarly, along with we have different kinds of object, plain object, plain simple Java object, enterprise Java beans, the stateful bean, stateless beans, and message driven beans, and things like that. Here we can use different stuffs. It is more complex. The enterprise edition is very complex as compared to standard edition. So if you are going to learn with enterprise edition, it is one of the major overhead a complex technology as compared to other implementations. It is far more complex than the PHP or Ruby on Rails or similar server implementations. However, the complexity helps you to design more secure and reliable ecosystem as compared to other backend technologies. The standard edition, as we all know, is the core. The enterprise edition consists of different kinds of libraries like Prime Faces, Java Server Faces, Java Server Page, JSP, that is the core thing, similar to PHP, or more things with different libraries. And you can develop your own libraries which could be implemented with Enterprise Java Beans uh, whenever you use. So a simple difference between the SE Enterprise Edition is that the Standard Edition is deployed over a desktop, or the Enterprise Edition is for internet. Similarly, we had a technology that mobile edition, but these are not used these days. In place of Java ME, we use Android Java or Kotlin for developing mobile applications, which is a member of Java family. So here we have different technologies that is being incorporated or used with enterprise edition of Java. We have servlets, we have JSF, Java Server Faces, the JSF Facelets, JSTL or Java Server Page Tag Library, the expression language for JSP and Facelets. We have JSP, we have Java Beans. The servlet are the core Java classes that we have to define for creating a request, getting a response, or for HTML pages. The same servlet pages can be written uh, other than by using Java. We can implement it with a JSP, that is simple text document that is compiled into the servlets, that is easy to read for those developers. Uh, Take a scenario, you are a Java developer and your friend is not a Java developer. He knows HTML, CSS, and PHP. So you are trying to build a server application. So if you are a Java developer and you are not familiar with HTML, you would certainly go with the servlet, the plain Java codes that are used to implement the backend logic or create a web pages with Enterprise Edition. Or if a PHP developer or HTML developer who don't know about Java, how to write Java programs, it would be better for him to learn JSP because it uses tags and different kinds of JSTL libraries that are similar to HTML and PHP more than Java. So for both kind of developers, we have the technology. However, you both can implement the same thing, the same backend logic with same power using either the servlet or the JSP. Similarly, we have different UI components that can be implemented with JSF. The server faces are the facelets that are hypertext HTMLs, extended HTMLs uh, that could be used with a JSP. And we also have an expression language that can be used in place of JSP as well. And when we have to use the different beans or kinds of temporary data storage or certain things, we can use the Java beans here. We are not going into very depth of the enterprise edition or either the standard edition, but we are the our objective here is to learn the difference between them and what we can do with these technologies. When it comes to enterprise edition, it can be integrated with different kinds of web libraries with HTML, CSS, and JavaScript like Servlet, and we can implement with a REST API, the POST API, the WebSockets, and the JSON, XML, and different things like that. We have the developer productivity with more annotated plain Java objects, boilerplate codes, and we can meet enterprise demands. We all know that different banking sites or banking implementations, transactions that are done these days are implemented with a Java due to its more security and functionality. There is a Java Enterprise Edition architecture, which consists of EJB, Enterprise Java Beans, JSP, Servlet. It issues the callback or enable functions that are initialized with the HTTP API or the client SSLs to the application server, where the application server uses the concurrency services or threads that could incorporate various standard editions or server editions, logic, or call the database or appropriate servers. It is quite complex and we're not going into in depth, but here to make you more familiar about these things, I'm just depicting basic things. In the enterprise editions, we have the browser from where a client can explore different kind of functionality, which may request different types of SSL secure socket layer or WebSocket request. We have the Java client that may be the desktop tool or a web utility, client website web page. Then we have different kinds of containerizations and different kinds of tools that are pre-installed on our application server residing on the server. The JDBC, JMS, Java Message Service, Java Database Connectivity, the connector tool, the Java Mail API, the security modules, the WebSockets, tag libraries, GSPs, and different kinds of things that are residing in the containers. Then we have the separate EJB Enterprise Java Beans container for compiling Java Beans. And then these are all linked to the database where all the data is stored. And we can implement the backend logic, fetching these libraries and APIs. We can create complex applications. With the JRE and the JDK, we already know the difference between them. With the JRE Java runtime environment, we have lesser things, and with JDK, which is a subset or superset of these things, we have more functionalities. So here is a comparison with the Java Enterprise Edition or the Server Edition comes in two ways, the Open Java or the Oracle Java. The Oracle Java, we have different kind of commercial things, and with the Open Java, we have more control over the technology, which is open source. The release cycle is roughly 2 years for on average. It will be releasing these things. So we already knew the difference between the standard edition and enterprise editions. Uh, Try to learn more and build your own solution. Keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn about JVM, JRE, and JDK, the difference between the Java Virtual Machine, Java Runtime Environment, and Java Development Kit. So let's start. These three are the vital components when it comes to compiling your Java programs and deploying it on a machine, be it a client or server. First, we have to develop an understanding of what these components are and how our code is being deployed. The JVM is the basic component called as a virtual machine, where we have bytecode. In the previous scenarios, where with the C++ or C programming languages, there we have the program code, a high-level programming language that is being written by a developer, which is being directly compiled to the machine code. Uh, but with Java, we have an intermediate code called bytecode, which is required to support a machine independence platform. For C programming, we have different machine codes for the same high-level instructions provided by a user or developer for different machines. Suppose I have an Intel machine, the ARM machine, or IBM machine. I have to compile my C program differently on different machines. So it will take time. But with Java, I have to compile it once in either of the machine and then export the bytecode dot class files by running it on different JVMs, virtual machines, on different computers. JVM uh, takes bytecode and execute the machine code for that instance. So it is an abstract machine which is used to function on the bytecode to convert a Java file into class file and class file to machine file. It is a specification that provides a runtime environment in which Java bytecode can be executed. Uh, it could be also useful for getting a programs that could be written in other languages and compiled directly to Java bytecode. We don't necessarily need a Java programming language for running it on the JVM. Languages like Scala and Kotlin that use the Java bytecode as an intermediate code also run on the JVM. The Android Java programs run on the special variation of JVM. Then these are the platform dependent. JVM, JRE, and JDK are platform dependent. It depends on the machine on which it is installed. It depends on the configuration of a different OS based on a Windows, Linux, or Mac. However, Java is platform independent. To make Java platform independent, these things have to be installed for different platforms because they will run the same instruction code or bytecode on different machines. There are certain main tasks for JVM that performs. It loads the code, the Java code, verifies the code, it executes the code. It provides a runtime environment for running those things. So here's the difference between these three things, JVM, JRE, and JDK. It could be understood here. Uh, First of all, we have a source file called Java files that is being compiled by the Java compiler, Java C, which is a component of JDK, Java Development Kit. Uh, it generates a class file which is provided to JVM, a Java virtual machine, which works with other libraries that are stored in the Java runtime environment. So JVM is a subset of JRE and JRE is a subset of JDK. So JDK consists of JRE and JVM and JRE consists of JVM. Here it is very simply done. So in certain devices, we don't need to install the complete JDK. We may also get our optimal results by installing the JRE as well. And in certain devices, like a smart TV or things like that, we only need a small component of JVM to execute the bytecodes. So Java Runtime Environment is an acronym here for JRE. It is also written as Java RTE. It provides the environment, which is set of software tools that are used for developing Java applications. When we are writing code on Java on our system, we need the JDK, JRE, and JVM all as well and together. But for running a user script, say if you have developed a website with Java and your client who is not a developer in Java, he need to download the applet code or view those things. He only need the JVM, not the JRE or neither the JDK. It is for development purpose only. So the implementation of JVM is done with the JRE. It physically exists. It contains a set of libraries plus other files that JVM uses at runtime. So here's the development kit where we have the complete API, the libraries and different things that we need to develop or write our code on the Java. So it is a completing. Here we get an interpreter, the loader, and the Java, the compiler, Java C, and the archiver, jar file, Java archive file, and document generator, the Java doc. We will be going to learn these things in the command scenario where we can compile or write and compile our code using the command prompt or terminal to complete the development of applications. Here the JVM comes with library classes to define the runtime environment, and if you add the development tools, it will be JDK. So there are different tools that are provided with JRE and JDK. With JRE, you get the Java interpreter, Java W, different libraries, and different set of jar files. With JVM, you got a just-in-time compiler to compile the bytecode, read, verify, and execute the bytecode. With JDK, you got a Java C, Java compiler, jar generator, Java archive generator, and debugger, the debugger tools, and Java P, the documentation, and different tools as well. It is a hierarchy how it works, the flow diagram. We have the source code, it is provided to JDK consisting of compiler. Then we have the bytecode on different set of machines. In our machine, we only generate the bytecode, so we need the complete JDK. But when we provide our class files or even the jar file to different machine, we only need that machine only need to have JRE or either the JVM only. So suppose we have, so how it is compiled. Suppose we have a file called example.java. The example is a class name. We will learning in the coming lectures. We have to compile the file, save the file, convert it, compile it to the class files, load it to different devices, machines, and where the JRE, the runtime environment, has to function different work. It has to load the class file, generate the bytecode verifier, and interpret those things, provide it to the runtime and to the hardware, the machine code which is being implemented there. So this was the basic different understanding of JRE, JVM, and JDK. These are not very complex things, but if you are learning to Java programming, you have to better understand where your codes go on the machine. Mm, we will be learning more in the coming videos. Till then, keep learning and keep moving ahead. Hi there, welcome back friends. Here in this lecture, we're going to learn about the new features that are present in the new release of Java 11. So let's start. So Java 11 is a pretty light on things that change the way you code. It will remove certain obsolete features and add new features with the ability for you to run single file applications, a large number of new APIs that are being included, and a small change in language syntax with the removal of Java SE dot enterprise uh, edition aggregator module, which may impact the migrating an existing application to GTK 11. So you could write a single file application without the need of a compiler or things like that. So there are certain features. The first thing is that we have a local variable syntax or lambda parameters, the stateless functions that are lambda functions where you don't need an implicit functions to write code. It supports a local variable syntax, uh, so don't no longer need an explicitly state the type of local variable, but you can instead use the variable as it is. The syntax for writing is you have to provide the variable names, arguments, and then with the direction symbol, the arrow, you have to define the process. So that is it. Here we also have the epsilon, which is a new feature that is an arbitrarily low overhead garbage collector. We have a garbage collector with a Java, Python, and advanced programming languages. But here we introduce the epsilon, which is a no operation garbage collector. And the purpose for this to develop a garbage collector that may handle memory allocation without implementing any actual memory reclamation mechanism. So it would be a very useful thing and helpful to clear the cache so that program may run faster and faster. We also have the dynamic class file constant uh, where we want to extend the class file format to support the new constant rule form, the constant dynamic. It is used to reduce the cost and disruption for creating new forms of class file constants using a single new constant pool that can be used to parameterize the user provided behaviors. So there are certain features that may not be welcomed by a different set of users or programmers. Not everyone is familiar with a wide range of things. And when you go into deeper with the Java programming, you would soon grasp these concepts. The new features here is to remove the Java Enterprise Edition and the Kurva modules, which is very invited and a long-awaited thing. The Corba modules and Enterprise Edition, certain libraries for Enterprise Editions, make it heavy weighted of the JDK. We don't actually, not every developer uses these libraries. So why we need to install that thing? So these features are depreciated and removed from the Java SE 9. It will be entirely removed from the entire Java SE platform and SDK in Java 11. So it is a cleanup process that started with SE 9. So here we have a long-term support. The long-term support for the Oracle that offers different points. You get a Premier support for database, Fusion middleware, or other availability modules. And the second offering is called Sustaining Support, which includes maintenance for as long as you use Oracle software. So here you got pre-existing fixes and different kinds of technical support with this version. So there are different kinds of releases, the OpenGDK releases and Java SE Advanced for customer. So these are being updated every time we have. There are a different set of APIs. I will not be covering everyone, but here are the few that are new in the family. The Java IO byte array output stream, which is used to write all the bytes of the parameters to the output stream. Here we have the file reader, which provides two new constructors that allow a character set to be specified. We have the file writer for same purpose. We have the input stream that points to null input stream, returning no bytes if it doesn't read. You can have different things here. You got the output stream for null output stream. You got reader, writer, character sequence, reference, language.runtime, and more APIs. The string buffers, and different features that are there being added on the library. So if you are working on a certain set of tools or libraries, or you're familiar with Swing or AWT utility, you may prefer usage of that thing. And when you're comfortable enough to code on that certain library, you would be uh, using the new tools or new features that are there present and released there. Don't try to use the version dependent features every time because your API may not work properly. Try building your own solution, and if you are advanced enough, you could develop your own library and release it to the public, which may be added in the future Java releases. Till then, keep learning and keep moving ahead. Hi friends, welcome back. Here in this lecture, we're going to learn about Java variables and Java data types. So let's start. For writing code in a programming language, we need variables to store certain values. Suppose we want to devise a calculator program which may calculate various operations like addition, multiplication, division based on different values provided by the user. Say we want to add two numbers or three numbers. In that case, we need to store those values in certain format. For the purpose, we have variables. The Java variables are containers that holds a value during the program execution. A variable is assigned with a data type. The data type here is integer, float, character, byte, double, or boolean. Or it may be also long or unsigned, assigned, various kind of things. We're going to learn about this data types and the variable here. So the syntax int value equals to 550. So the 50 is the number numerical value that we want to assign or store or use throughout the program with the name as value. Whenever we want to print value 50, we will be using this keyword value because this is a variable, user defined variable. We can write v, we can write x, we can write anything in place of value. But the type that value variable is storing, the integer value, it will be denoted by the data type. So we are writing int here. So there are different types of variables. The local variables, the instance variables, the static variables, these are different categories on which the variables can be defined. Data types are of integer, float, character, double types, and the variables are for local, instance, and static variable. Uh, we are currently writing any program in the main function that we have learned in the earlier lecture. The main function is the first function which is to be executed by the compiler, and any variable which is defined or declared inside the body of the method is called a local variable. The current method. Suppose we are in a different method, say xyz. So the variable which is defined in the xyz function or method will be considered as a local variable for that function. We have instance variables that are declared inside the class but outside the body of the method. So in any program, Java program, we have a class, we have a function or method. Outside the main method or any other method, the variables which are defined are instance variables. We are going to learn about these things. They are not declared as static, when then they are considered instance variables. And static variables, that the value of variable you could not change, and it could not be local variable. It has to be defined outside the class. So you can create a single copy of a static variable and share among different instances of the class. So the variable in the program execution, we may change the value of the variables. We will be learning in the loops and different sections. So don't worry. Just get these three categories, or if you do not get, these are the lectures denoted having different meanings in different contexts. So here is the introduction. You get these categories, and when you are writing a loop or other complex programs, you could refer back to this lecture and find out what is the difference between local and static variable. In the loop, we are going to use a value, integer value like I, which will be used for incremental purpose. So the value is being again changed and changed over a time. So when we don't want a variable to be changed, it will be used as a static. You're going to understand it in a later time period. So skip that thing. Here we have a typical example for defining the data types and variables. So we have a class A. You have to define a class. You have to provide a method, main method, public static void main method, and there we have different variables. So this is the syntax. The int value equals to 50 that we have seen earlier. Example, it is a variable. The variable is called value, storing a value 50 of the integer type. Similarly, we may have another variable, say x, having different value, say 100, and it could be made static. The static keyword could be added before the data type name. So the static value could not be changed. We could not modify the value of x during a program execution. However, we can change the value of non-static variables. Static variables could not be changed. In the later section, we have a method which is defined, a void method, and here we have the integer y equals to x, or y equals to 90. So the variable y is a local variable of method, this method, and the above methods are not local methods, so they are called instance method and static variables, instead variable and static variables. Similarly, we can have a long range of instance variables, static and local variables throughout our program. So here comes the understanding of data types. We have variables, we can provide any value. So how we can define what kind of variable values they are storing. So the data types are generally divided into two categories, the primitive data types and non-primitive data types. The primitive data types are the basic data types that are defined in any programming language. They may be numeric or non-numeric. The non-numeric values contains character and boolean. The character may store a single character value, say A, B, C, D, any value, any alphabet, being it small or capital or different special symbols. And the boolean will store only two values, true or false, or could be said as yes or no for any logical operations. It could be performed using AND, NOR, and logical gates, or as well as in simple scenario. Suppose we want to execute certain section of the code when an input is provided by the user. So we will take, if the value of integer is true, it will be executed, otherwise not executed. In other cases, we have numeric values to store numeric functions to perform numeric operations. The numeric values can be integer or float. Float means decimal values. The integer could be a single byte, short, integer, that we have used int, the long to store a long number of integers, and a floating point, which make be of double or float. Double is the numerically double of float. It could store uh, values preceding the decimal point in the both directions. So we can use float for adding storing um, different values, the floating point values. Then we have non-primitive data types that are not defined in general programming language. It will be defined using a set of rules based on class or different advanced functions, but could be used by a general programmer as a primitive function. These are strings, arrays, and user-defined classes. So the strings are a set of characters. With non-numeric data type, character char, we can store a single character. But if we want to store a complete sentence or complete word, we can store it using the strings method, string of character to be short. And then we can have array, a sequence of integer or floating point values, or any character or boolean values. The array is simply a table, a one-dimensional, two-dimensional, three-dimensional, or multi-dimensional. It could be performed. We can create matrices out of arrays or different things. Perform wide range of mathematical as well as a different set of operations. The entire data structure is based on this concept. Then we have user-defined classes that are also defined as non-primitive. We are going to understand each one of them in the coming sections, and it will perform using practicals. So here is an example of different variables. We have a class consisting different kinds of variables. Uh, we have the long value uh, denoting preceding with the L. We have the float value. We have the boolean value. Boolean takes a true or false value. We have the character value. Character has been any single character. We have the string. Any string could be stored here. Then there is a range of numeric data types in Java. For byte, we could have 8 bits of size and can store values from -128 to +127. It can store any value. So it would not be storing +130 value in the byte. So be careful. Suppose you have two byte variables having values 20 and 480, sorry, 20 and 127. It could not be added and displayed as a byte. It would be displayed as a short. Then the short could be having a value between 32,768 minus and 32,767 in the positive range, having size 16 bit each. Then we have integer, long, float, and double values. So for advanced mathematical operations, for scientific calculations and such things, we need double, float, and long values. But for normal things, we don't need these things. And then there comes a typecasting. The typecasting is used to convert the data type of a certain data type variable. Suppose we have a variable called a integer and we want to typecast it to float or integer. We may typecast it using the bracket symbols. We have the floating value, say f, which is a float variable, having value 18.92 in the float value. And we want to display it as an integer function. We have to define a new variable with this different format, different data type, say integer, and assign it with the int typecast of the f variable. So it will be displayed as here. System out println would be used to display the variable value on the screen. So the first line will display 18.92, the value of f, which is float, and then the second line will display a, which is 18 on the screen, the integer part of that thing, not the decimal part. Then there comes a Unicode system, which is a universal standard for character encoding that we use in the most written languages. Earlier in programming languages like C or more primitive languages, They were using ASCII code, American Standard Code Information Interchange, supporting only alphanumeric characters of the English language systems or Roman script. But with the Unicode, we have a more control over different languages and internationalization support as well. So now we can write programs having syntax like languages in Japanese, Chinese, Hindi, Bengali, Punjabi, Tamil, Telugu, Arabic, or different sets of the world's language. Different languages are being included, different character sets could be identified in the Unicode system. Java is a programming language that supports Unicode. So you could use and define the systems or softwares that will be designated for a different set of audience. Suppose you want to develop a software for Chinese audience in the Chinese language. You will be coding in the plain English language, but you could use the syntax of Chinese languages as a user display mode or different things. So the Java would support the designing of that software, which could not be done with C or C++ in any way. So this is the power of Java. We learned about the variables and the data types. On the typecasting, we can change the values. Uh, we are going to perform the practical session. So till then, keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn about Java command. So let's start. There are various statements that are not executed by the compiler and interpreters. These are called comments. Comments can be used to provide information or explain about variables, method, class, or any program statement. It can be used as a program code specific for type, and we can use comments for wide range of usage. Suppose we are writing a program in a development environment where we have to work with a team, and there is a replacement going on every 6 months. So the developer need to be changed every 6 months. So the new developer need to understand the existing lines of code and write new codes based on those. So he or she may need a proper documentation as well as a particular comments and used sections. So we need to write comments on that cases. Even if you are trying to make tutorials, you need comments. Or for your own aid of mind, you memory aids and different kind of things. Or you're writing signatures, it could be used as comment. You could write your own signatures as painters do or artists do in your own code so that your code may not be stolen or lost. That that's may the reason you may need to write comments. These are not executed by either the compiler or interpreter. It is just a key, just a string of words. There are generally three types of comments available in Java, so you can leverage your work from here. There is a single line comment, multi-line comment, and documentation comment. So let us understand each one of them in detail. The single line comment, you could add comment that is applicable only to a single line. So it may not exceed the limit of a single line. When you press enter or move to the next line, the scope of comment has been gone. So you have to first define the comment by to backslash. Just need to write that to backslash and write your comment. Here we have a variable int data equals to 1 and the next line is comment which is written after the slash, double slash. This is a single line comment. Similarly, we may have a multi-line comment which may have a scope ranging from different lines. So here we have the starting option and the closing option. The starting is denoted by a backslash and an asterisk symbol, start, and the end is an inverse of this thing, asterisk and a backslash. Here we can write multi-line comments. This is the comment between multi-lines. And then we have documentation comment, which is need to use to create documentation in the APIs. If you are advanced enough and you can create your own API or set of functions or libraries for the programming language itself, You may need the Java doc tools in order to create such thing, and you can write a documentation comment in order to subscribe and add details to your methods. So it will be started from double asterisk and rest remains the same as multi-line command. So you can use any of the commands, be it single line, multi-line, or documentation command to empower your coding or empower your program. We are going to learn more. Till then, keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn about Java operators and different types of operators, be it unary, arithmetic, logical, shift, and different set of operators that we can perform during different functionality of a program. We can perform calculations, we can perform shift operations, we can perform logical operations, we can perform increment, decrement, and a wide range of things using the programming language. So here we are going to learn these things. Let's start. So there are various kinds of operators in Java, which are symbols that used to perform various operations. For example, subtraction, addition, multiplication, division are various symbols. The subtraction is denoted by minus sign, the addition is denoted with the plus sign, and so on. So there are various kinds of operators or types of operators in Java which are being supported here. Few include the unary operator, arithmetic operator, shift operator, relational operator, bitwise operator, logical operator, ternary operator, and assignment operator. So we are going to learn each one of them step by step. So the unary operator are operators which are performed on single value, single variable. Suppose we want to add two numbers, we have two variables. And if we want to increment the value or decrement the value of a variable, suppose our variable stores a value 10 and we want to increment it to 11 or 12, we can use this unary operator. Or if we want to decrease it, we can do so. Similarly, arithmetic operation is done between two variables and the result is stored in the third variable, like addition, subtraction, multiplication, division, modulus, and more things. The shift operator is a logical shift operator. Uh, the shifts the value of the binary notation in the 0 1 format. Shift the value to the left or either right one. The relational operators that show relation between them and or not or such things. The bitwise operator on the binary operations, bitwise and bitwise or the logical operations and or not, the ternary operator on three objects, the assignment operator like equal to which assigns the value of the rightward thing in the leftward direction. So when we are using different sets of operators, there are various scenarios where the conflict may occur. So to give the priority of to the which operator. But for that case, there is a scenario where operator precedence is denoted. So there are various precedents of the operation, and here the operators are like addition, plus symbol for addition of two numbers, subtraction, multiplication, division. Modulus, the percentage symbol, is used to divide the two number and return the remainder. If you divide 10 by 2, it will store the value 5, but the modular symbol will store the value 0 because there is no remainder. There are various cases in programming, you will be learning it, where we need the remainder value. If you want to find the even numbers or the odd numbers, you would be requiring this thing or display certain pattern. If you are going to write code for the competitive programming, you will be using this operator very much. There is increment operator. The double plus symbol increments the value of the variable. We have a variable called a having value 10. If we write a plus plus, it will increment the value of a from 10 to 11. Similarly, we have decrement operator, which is a double minus symbol, which can be written before or after the variable. So it is an unary operator. So there are different precedence sequence. The unary got the highest precedence, the plus, minus, double plus, double minus, not. exclamation mark, or tilde symbol, brackets. Then we got arithmetic operators on the second preference, the shift operator, comparison operator, logical bits, boolean, ternary, and assignment. Assignment got the least preference at the last. The ternary operator include if else statement, a question mark, if then else, evaluate. This way. The Java unary operator consists of one operand. Only one operand or variable is required. It can increment or decrement the value by one. It can negate an expression. Suppose we have an expression called a plus b, and if we put a bracket symbol, it will be treated as a single operand, and we'll write the negation symbol tilde. Inverting the value of a boolean, we can use this thing. To reverse the value of true to false or false to true, we can use this thing. So here is the demonstration of using the unary operator. The first, we have the variable called x having value 10, and if we write x plus plus, it will increment the value of 10 and display the output 11 afterwards. If we write plus plus x, it will right away display the output. Remember that placing the double plus symbol or increment symbol after the variable will print the value of the current variable without incrementation and then increment the value. That means we have the variable x having the value 10. If we write x plus plus, it will display 10 on the screen and then increment the value for the later use. If we write plus plus symbol before a variable increment value, it will first increment the value, then display it on the screen. So it will display right away at 12. Similarly, for the negation symbols, there are Java arithmetic operations like addition, subtraction. Um, Here is an example of this thing. Suppose we have two variables, a and b, a having the value 10 and b having the value 5. If we simply write a plus b, it will show the result 50. It will add the two variable values. If we write a subtraction symbol, it will display the difference between them. If we write multiplication, the asterisk symbol, it will asterisk or star, it will display the multiplication, similarly division, and the modulus that I explained you. The division, if we write a slash b or division symbol, so the a will be divided by b. 10 will be divided by 5 equals to 2, that is quotient. If we write modulus or mod, it will display the remainder. The remainder here is 0. Similarly, if we want to perform complex arithmetic operations, it will be denoted using the precedence operator. You might have heard about the BODMAS. The same applies here. Bracket of multiplication, division, addition, subtraction. So the bracket and multiplication got the highest preference, and the subtraction is given the least without brackets. If you do not specify brackets, if you specify bracket, it will be given highest precedence. Similarly, there is a shift operator, the Java shift operator, the left shift or right shift, that is used to shift all of the bits in a value to the left side of a specified number of times. You might be working on binary data. There are values like 0, no, 1, 0, 1, 0. So if you want to perform left shift, it will shift the value of each bit leftwards one time, and so on. So here, if we have written a syntax like 10 double arrow 2, it will shift to the value of 10 two times. The value will be displayed as 40. It will perform on binary and the result will be displayed on the decimal. Similarly, we have the assignment operator where we can assign value to the left one. The equation symbol equal to or plus equals to minus equals to are all assignment operator. If you want to assign a value 10, say 10 to a variable called a, it will be written as a equals to 10. So the rightward value is assigned or stored in the leftward value. Similarly, if you want to perform addition, uh, successive addition, or successive subtraction. We can perform it using a shorthand operator. Uh, we have, if you say, if we have a variable a having a value say 10, and we want to add 4 to a. The format of writing this thing is a equals to a plus 4. It is a repetition and long phenomenon. We can substitute this for a plus equals to 4. That means a equals to a plus 4. Similarly for subtraction. You could use, this is optional, or if you are uncomfortable with this shorthand, you could move it to the longhand operator as well. Both works. Yeah. Then we have logical and bitwise AND operator. The logical operator and the bitwise operators are different things. The logical consists of AND or NOT. The AND is denoted by double ampersand symbol. NOT is denoted by double pipe symbol. Sorry, OR symbol is denoted by double pipe symbol, and NOT is displayed with exclamation mark. Similarly, for bitwise AND, we have single ampersand. Bitwise OR is simple pipe. The logical operator does not check second condition if first condition is false. So the difference between here is the logical operator, if first condition is true, the second condition is true, both need to be satisfied. So suppose here we have three variables having three different values. So here we have the first output A uh, is smaller than B, and the logical AND A is smaller than C. It will check the value if A is smaller than B. It is true. Uh, is smaller than B. It is not true, false, because 10 is not smaller than 5. So it will return false. And the later condition is true. So it will return false because both conditions are not true. The logical AND doesn't check second condition if the first condition is false. Similarly, here, in this next case, we have the bitwise AND operator, which again makes a check, and the first condition is false, the second condition is true, it will again return false. The bitwise operator always checks both conditions, whether first condition is true or false. Similarly, the AND is displaying AND will display true only when both conditions are true, both logical and bitwise AND. We can use those things in different scenarios. Similarly, we have the ternary operator, the if then else condition, by writing using those two symbols, the question mark and the double dot symbol. We have a condition, then we have the block which is executed when the condition is true, and then we have the second block which is executed when the condition is false. Suppose we have condition like if a is greater than b, if a has value 10 and b has value 5, it will move to true section or the block 1. Block 1 is executed. If it is false, it will be executing block 2. So this is the way of writing this thing. So here it is. You can move with the error section. Uh, Here we have the condition A is smaller than B. The question mark symbol A, which is the block 1 first condition if it is true, and B if the condition is not true. Similarly, we have the value A equals to 10, B equals to 5. A is not smaller than B, so it will execute the B statement as print B. So the minimum value will be printed. It is used as one-liner replacement for if-then-else statement and used a lot in Java programming. So these were about the basic operators that are used in the programming language in the Java. You can make use of a wide range of operators, operands in the same format, and we are going to practice it well in the practical sessions. The operators demand a huge practice, and it is very easy, not a difficult task. But if you are working with logical operators and shift operators, you must be careful enough to display the output. You need a certain practice and write a different set of programs. You can design your own calculator a different set of calculators, logical machines, lie detection machines, program, and such things. Uh, Try building a all solution. Till then, keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn about Java control statements. And here, particularly, we are going to start with if-else and various kinds of if-else statements that we can write to support segment-based control structure on our programs. There might be different scenarios in which you want to write different predefined conditions, and based on those predefined conditions, you want to execute a particular segment of the code based on different options, yes or no. Suppose if an event occurred, you want to execute certain code. If another event occurred, you want to execute different segment of code. Say if the user provided his name and his name starts with A, then the message will be displayed as welcome a person whose name starts with A, and so on for till Z. So you have 26 cases for 26 characters A to Z. So that could be defined here. So here is the basically if-else statement. We have the predefined conditions. The control loop starts from the above, the starts of the code. That could be print statement, class, main, etc. And when a program reaches to a certain condition, which is a predefined conditions, it will check whether the condition is being satisfied or not. The condition could be like if a equals to 10. We have a variable called a, and the value is being taken from the user as an input, and if the value provided by him is 10, we may check whether if a equals to 10, then we can execute the conditional code, the segment which is executed when the condition is being satisfied, and if it is not satisfied, then it will move further out of the section and it will be taken as else statement or other. So this is a simple if else statement. You can base add conditional checks and different things. It is used to check the conditions, and it may check the true or false of the statement, existence or non-existence. There are various types of if statements that we can use. We can use the control statements in two ways: the case, switch case, and if else. So here in this lecture, we're going to learn about if else. There are different cases. The first is if statement. Only if we have only one condition, and if that condition is being satisfied, it will execute the code, and we do not define more than one conditions. In the if else statement, if the condition is get false, what should we do? That is being provided in the else statement, and the rest of programs will be continued. Then we may have different situations in which we may have different if else statement, if else ladder, if, else if, else if, else if, and else. We are going to learn about all of them in detail. Suppose you have different cases. If a person's name starts with A, you want to check in the first condition. If the person's name does not start with A, there may be situation where his name may start with B. Then we have different case for B. Similarly for C, D, and E, so on. And the else statement would take the conditions which are not alphabetic. Say numeric, a person's name could be start with a number. Then we have nested if statement. If inside another if. If we may want to check conditions in a scenario, say if you want to check whether a city is situated in USA, you would check the conditions first of all. If a city is situated in North America, then move further. If it is situated in USA, then it will raise the flag and check whether the city is in the list or not. If it is not situated in North America, it will not move to the another if conditions. So the execution time would be same. So this is the first example. Here we have a number value defined as 13, and we are going to check whether this number is divisible by 5 or not. Divisibility is checked by taking the modulus of that function that we have learned in the earlier lectures. The division will remain the division sign, the slash sign will give you the quotient, and the mod sign, the percentage symbol, will give you the remainder. If the remainder is not equals to 0, we can get an odd number. If the remainder is equals to 0, we may get an even number. So this is the concept. So we will write it as follows. We have to write if provide in the brackets the variable name and the conditions that we want to define. Here we have a variable called number, and we want to check whether the number is divisible by 5 or not. So we will write number mod 5 double equals to, in order to compare if the value on LHS left hand side equals to RHS right hand side. So if value corresponds to 0, it will print this statement, even number, or if it is not, the remainder is not 0. In that though the all case, we will have this statement being executed, which is defined under the else condition. Remember to place the curly braces and the brackets properly. The brackets condition is only defined in the if statement. There is no condition defined in else. So if the if condition is not true, then for all other conditions other than this, else condition would be executed. And any one of them could be executed, not both could be executed in a single case. Then we have if else later. There may be different conditions corresponding to different statements. So if we want to check whether the first condition is true, if the first condition is true, the condition statement will be executed and it will move out of the control. Then if the first condition is false, then second condition is being checked. If it is true, it will be executed. First will not be executed, and not other statement will be executed and will move out of the loop. Then if both conditions, first and second, get false, then third condition is being checked, and similarly till then, whatever we have. If all conditions get false, we have the else statement. So this is an example. Here, suppose you have opted for an examination and you got certain marks, and you want to design a grading system software to decide whether which grade you obtained based on your marks. So suppose we have obtained 72 marks and we want to check whether which grade we have obtained. We have to first write a condition. Here the passing marks is 50. So if the marks is smaller than less than 50, it will display as the fail. If the marks is greater than or equals to 50 and marks is smaller than 60, that means 50 to 59, it will print D grade. Note here that double ampersand symbol corresponds to AND, which is being checked if both conditions are true. If both conditions are satisfied, then only this statement will be displayed. Otherwise not. Then we have if marks is greater than equals to 90 and marks is smaller than 100, it will print A plus grade, and as for all other conditions, it will print invalid. So here we have 72 marks, which is neither the fail condition nor D grade because it does not fall in the 50 to 59 category. It is neither A plus grade, but it will be considered as invalid. Yeah, this is an obvious case. You can design your own case. You can print a different messages based on age, gender, and things like that. Suppose you want to design a system for any election voting system or things like that. You may want to check whether the person's age is above 18 or any criteria, whatever you feel like. Then we have a nested if statement. The nested if and if condition within another if statement. So there is an entry to the condition 1, first condition, which is being checked. If the condition is true, then we move to second condition. It will be checked. If the second condition is true, the statement for second condition is being executed and it will follow next statement out of this condition checks. If the second condition get false, it will print the second statement. And if the first condition, the basic conditions will get false, the third statement will be executed. You may provide any of the statement, or you don't need to provide all the statements. This is a typical scenario where we have a nested if example. If a block is within another block, so the inner block condition is executed only when outer block is true. Here we have two conditions. We have two variables defined: age in integer format and weight in integer format. We want to design for the blood donation camp, and we want to take blood of people who are above 18 years of age, 18 or above, and their weight is more than 50 kgs. So we have to first check whether their age is greater than 18, because there might be certain people below the age of 18 who have weight 50 and above. So it will be wastage of time and processor clock time of the processor if we want to check weight at the first. We have written the if statement at first. If age is greater than or equals to 18, then it will move to the second condition. If weight is greater than 50, then it will print eligible for donating blood. Otherwise, for any other conditions, if both conditions are not satisfied, you can display sorry, you are not eligible. And you can simply opt this out if you don't want to provide any condition for that. The similar things could be implemented with switch case that we're going to learn later. Try building your own solution. Uh, if else is a very powerful tool, and without if else or control statements, you could not define or imagine a programming language or a software. So try, give it a trial. Use nested if else later, and everything. Uh, keep learning and keep moving ahead. Hi, welcome back, friend. Here in this lecture, we're going to learn about switch case control statement. We have learned about if else ladder, and nested if, and similar logic of the conditions, predefined conditions, and we can test various cases or variables based on certain conditions that we define. We can implement it also in the switch case format. So let's understand what is switch case. It can execute one statement from multiple conditions. It is similar to if else ladder and test the equality of variable against multiple values. Here we have the variable, so we can have a variable called n equals to 20, say that we have in our example, and we can test the value of n in the switch case format. Suppose here we have n equals to 20, we may have the user input, and a user may provide the value of n. We do not know which variable which value he will provide. So we can define different cases, and we can generate different outputs based on different input. So we have the switch statement that may switch that input variable called n. We have to write it as switch in brackets n, the variable name. Then we can define different cases. Say cases correspond to different values of the variable. Say if the value of a variable n equals to 10, that is called case 10. It will display the output as 10. Similarly, if it has the value called 20, it will display the output 20. Similarly, if we have output 30, we can display 30 and things like that. And if none of the case corresponds to the value of a variable, it may execute a default block, which is similar to else statement in the if else ladder. But here is a difference between switch case and if else. That if any condition of either the if, else if, or else, any of the condition is satisfied, it will move out of the conditions. It would do not check any other conditions. But with switch case, if the first condition gets true, it will check all the next and coming conditions and display all the outputs until you provide a statement called break that is written after each case statement. We will learn it about in detail. So let's move further. Here is the diagram of a switch case statement. We have the switch condition, and it will check for the each cases in the flow diagram. If the first case is being compared, or if it's satisfied or it corresponds to the true value, The statement corresponding to the case 1 will be executed. If it gets false, it will test again the second condition, and similarly, if none of them is found, it will display the default output. And if either of the any cases or default condition is executed, it will move out of the switch case statement. With switch case, there are few considerations that we have to keep in mind before writing switch case programs to use the complete power of that. We can have one or n number of case values. We can have single case. We can have a lot of cases, thousands of millions of cases. However, no one writes thousands of cases, but we can have. We can also support a nesting of the switch case statement. The case must be of switch expression type only. The variable that we provide in switch, that variable format is also always in there. In the earlier example that we used the integer format, a numerical value. So we can have cases like case 10, case 20, case 30, but we do not have cases like case A, case B, because that has correspond to string or character value. We have to keep this thing in mind. The case value must be unique. In case of duplicate value, it renders the compile time error. We cannot have multiple cases corresponding to the same value. We cannot have two case statements corresponding to the same value 10. We can have only one condition for one check. The Java switch expression must be of type byte, short, int, long, enums or strings, enumerations or strings. You can use either of the format. Each case statement can have a break statement, which is optional. You can omit this thing if you want to execute everything in the forthcoming things. When control reaches the break statement, it will jump the control after the switch statement and move out of the switch case block. If break statement is not found, it will execute the next case. The case values can have a default label, which is optional. So this thing is not an error without the use of break statement. If you want to check multiple conditions, you can implement a nested if or if else letter in the single switch case statement. You can do so. When you will write different programs with switch case and if else, you will better get grips over that thing. So it is a very powerful thing. The switch statement is fall through. As we all know, if we do not write the break statement, it will execute all the statement after matching the first statement. So we have to be aware of this thing and prevent it if we do not need. We can add switch statement with a string. Suppose we have a string called final, which is string. This is final is the value of the variable text. So we can provide this variable or the string in the switch format, and we can check if the case is string value correspond to first, second, or any of the thing. It may and remember, we have taken the display output system.out.println as our examples. We do not need to display everything on the screen. We can implement different logics. We can erase flags, add multiple conditions. Suppose we have a game, we have defined a game, and we want to check whether in which level we are currently playing. So it could be defined here like level 1, level 2. We can have different cases like that. We always do not need to print output on the screen. Similarly, we can have different cases. We can have nesting of switch case, which is complex but very organized. Try implementing your own solution and give it a trial. Try implementing different switch case statements and execute it on your own pace. Keep learning and keep moving ahead. Hi, welcome back, friends. Here in this lecture, we're going to learn about loops. Loops are iterative statements that produce a repetitive function multiple times. If you want to execute a certain section of code or different statements multiple times if, based on certain conditions, you could do so using for loop, while loop, and do while loop. So we are going to start our journey with for loop. Here we start. We have loops in Java. We have three kinds of loop: for, while, and do while, based on different conditions. They are used to execute a different set of instructions in a repeated manner until the condition stays true. We can execute in for n number of times, be it definite or indefinite, until the condition remains true. So the first of all, we have the for loop. All three loops starts with an initial condition which is being defined. If the initial condition is being checked, we have to check a particular condition. With for loop, we have a condition in a particular range or sequence which is predefined. If that range value remains within the range, say if we have to count numbers till 100, we have to count within the range of 100 with a following increment, maybe of 1 or 2. And if this condition remains true, we have the condition statement that is following this for loop would be executed, otherwise it will remain out of the loop. If with while loop we have the conditional check at the beginning, which is indefinite, we do not know how many times the loop may be executed, so we may have the conditions until this thing remains true. While loop is used in various scenarios. Say if we have 1,000 students and we do not know whether they are male or female, and we have to check what they have, what is their gender, and we have to ask them, and we want to execute code for female students only. So we do not know actually how many female students are there and how many times the loop may be executed. So we can have the conditions like until the students remain female and which is not completed yet. So it may execute one time, zero times, even 1,000 times in that case if we have a number of students as 1,000. With a repeat loop or do while loop, we have the text executed at first, and then after the loop has been executed, we have the condition check. With the while loop, we have the condition check at the beginning, and with the do while loop, we have the condition check at the end. That's the reason do while loop execute one more time than while loop. We are going to learn in detail about these things. So let's start with for loop. For loop is used to iterate a part of the program several times if the number of iteration is fixed. And we already know the number of iterations in for loop. It is recommended to use for loop. There are different types of loops that we can use with for loop. We have simple for loop, we have for each or enhanced for loop, we have labeled for loops which we can use. So here we is the flow diagram for loop. We have the variable initialization, we have the termination condition, we have the statement inside the loop, we have the increment decrement operator. First of all, say if a variable I we take and the value is currently 1 and we want to execute it 10 times. We have the initial condition equals to 1, then we have the termination condition equals to 10. Until the value has been raised to 10, it will execute. So currently the value is, if you are executing the loop first time, we have the value 1. The statement inside the loop will be executed because the condition termination condition remains true. After the condition has been executed, we have the increment or decrement operation. Here we have increment of 1, say. If we have an increment of 1 starting with 1 and terminating with 10, this loop is expected to run 10 times. After the value has been raised above 10 or 11, this loop condition gets false and it will lead you to outside the loop. So no more execution of the statements inside the loop. So it will execute only 10 times based on the termination condition. So this is the format of writing for loop. We have the initial condition as int I equals to 0. You do not need to explicitly define the variable itself here. You can define a I variable anywhere above the program as we traditionally do, or use this value directly I equals to 0 without writing it. Then we have a semicolon which separates the initial condition to termination condition. Then we have the loop continuation condition or termination condition. When the value of I remains smaller than or equals to n. We do not know the value of n right here. It may be provided by the user also. Then we have the increment or decrement condition. Here we have an increment of plus 1, which is an unary operation here. Then we have the condition body of the loop that is being executed or performed when a loop condition remains true. We all have to place the loop conditions within the curly braces. Here we have a display value of I, a space, and a power, these two variables. And then we calculate or repeatedly change the value of power based on different conditions. So as initially we have value of power equals to 1, and the first time it will be executed, the power will be taken as displayed will be 1 and would be calculated as 2 for the next loop. If when i's value get changed, say 1, the second time the loop is executed, the value of power being displayed will be 2, and the third time 4, and this way. This is the format of writing for loop. Similarly, we may have a negation or decrement in the loop as well. We may start in the ascending order as well as descending order. Earlier example, we have you started with a 1 and terminated with 100, and here we have a termination condition as 1 and initial condition as 100. So we are supposed to subtract it or decrement it based on order. So this loop will display you the output of numbers from 100 to 1 with a difference of 1. In a new line, we have the statement print ln that will print every statement in the new line. Then we have a for each loop, which is based on a condition. It may perform an array. We are going to learn about array later. The for each loop is used to traverse array or collections in Java. Array is a set of elements. We know integer, float, character, a double, and different data types. Array is a collection of similar data type elements. It is easier to use than simple for loop because we do not need to increment the value and use a subscript notation in for each loop. It has a it works on elements basis, not on index. So we do not need to provide the index value, say I equals to 1 or 10. It will execute one by one in the defined value set. So the format of writing this for each loop is we have a for loop. We have to define the condition, initial value, variable say I, and place a colon and provide the array name. So it will display or execute each element of the array one by one. It would be useful for performing various set of operations. Say if you want to calculate a percentage of particular students, so you would be interested in calculating, adding the marks of all the subjects and then performing operations. You can calculate the percentage, average, and more things. You can also perform percentage if you want to get a school average. If you have percentage of each student of the school, and maybe there are thousands of students associated in your school, you could calculate using for each loop very well. Then we have a labeled for loop. In case there are various for loops, remember here that we can place for within for. We have nested for, and that's the reason we can create a very creative things like different patterns or images right there on the screen. We are going to practice it later. Uh, we have for different statements for, and we can set different labels that could be used as a reference to be executed anywhere from any segment of the code. Suppose the first for loop is considered as A and second for loop as B. We can break B anytime within the B and start A again or anything like that. We can have name for each loop in Java, and it is useful that we have nested loop and we can add break and continue specific for different loops. We are going to learn about continue and break statement in detail later. So this was about a for loop and a brief starting with the loops. Loops are very powerful thing. You can create a different things out there. If you're preparing for competitive programming, you could leverage this phenomena. Or if you are writing programs for any software, you would need loop for different conditions. Try building your own solution, keep learning and keep moving ahead. We have learned about for loop, and here in this lecture we're going to learn about while and do while loop. So let's start. Uh, while loop is similar to for loop, but with a difference that here we do not know how many times a loop condition may be repeated but performed. So we use while loop. We have a condition check. There is no termination, initialization, or uh, increment decrement condition defined here as the base. However, you may define it, but they are not required. We have only the base condition, and if the condition remains true, the conditional code is executed, or when the condition gets false, it will lead you out of the loop. With the while loop, which is used to iterate part of programs multiple times, the number of iteration or number of times the loop will be executed is not fixed. It may change with certain conditions, or it is recommended to use while loop. The example of while loop is simple. We have thousands of students and we want to check whether which of them were female students. And we have for female students, we have the condition like until the value student gender remains female, we have to execute this thing. So uh, here's a simple example. We have the initial condition I equals to 1, the value of I being 1, and we have to perform until then unless the value of I is smaller than or equals to 10. It will display the output. If we do not have the increment or decrement condition right here, which is optional, this loop will be infinite loop because there is no increment and value remains 1 every time. So while loop may be certain times become indefinite or out of control. So you need to proper check what you're writing in the while loop. It will produce the same output as for loop, but you have a better control over that or with limited foundations. You can have infinitive or infinite loops. Similarly, if we initialize the value of while being true without using any variable, we have the then do while loop, which is similar to while loop, but there is a difference. It will execute the code first, then it will check the condition. In the while loop, we have the condition check at the beginning, and with do while, we have the condition check at the end. It is used to iterate part of program multiple times, same as a while loop. Number of iteration is not fixed as while loop, and this loop will execute at least once if even the condition get false. So it is recommended to use while loop if you want to execute the loop at least once. There might be certain cases like that. This is the way. Here we have the conditional code which is being executed, and then we have the condition. If the condition remains true, it will lead you back to the condition code. Otherwise, it will lead to next condition outside the loop. This is an example of do while loop. We have the condition check after the do loop. We place everything within the curly braces of the do loop and while is placed outside the loop. So this was about a do and while loop. We're going to learn about class, objects, and various object-oriented and different concepts related to Java programming in the coming videos. Till then, keep learning and keep moving ahead. Welcome back, friends. In the previous lectures, we have learned about various control statements, be it loops, for, while, do while, or if else, and do case switch conditionals. There are various scenarios in switch case or if else conditions and as well as loops that we need to have various controls in our program. We may want to start or stop or resume or pause from any segment of the code and start it anywhere else. For that reason, we have two specific or advanced features that is called as that is called as break and continue. So here in this lecture, we are going to learn about break and continue statements. So let's start with break. Break statement is encountered inside a loop or any kind of control statements, and the loop is immediately terminated, and the program control resumes at the next statement following the loop. The Java break is used to break loop or switch statement. It is used in switch cases where we want to terminate the switch case statement when a certain case is encountered. We have to place break after each case, otherwise each condition will be executed. And we can also use it in for loops, while loops, where we want to move out of that loop. It breaks the current flow of the program at specified conditions. In case of inner loop, it breaks only the inner loop, not on the outside loop. If we have two loops, one nested inside other, if the inner loop is break, it will move out of the inner loop and start with the outer loop, continue with the outer loop, and so on. This is a typical scenario. In the for loop, we have different conditions. Let's say if else, and we have initiated a break statement just after the if. If a condition has matched, it will break the for loop, move out of the loop. If it does not match, it will continue normal execution. Similarly, we can place it in while loop in any case or control statement. It may be used to break the inner loop uh, on the within another loop. Here we have two for loops. One for loop is inside another for loop based on different condition, and if a certain condition is matched, here value of when a value of I tends to 2 and value of j tends to 2 simultaneously, then the break is initiated and the inside loop is being terminated and the for loop is being executed. If this value is not terminated, the system.out.println and the display on the screen will be initiated for I and j values. When you break in while loop, it will move out of the while loop as well. Similarly, we have the continue statement that has the same functionality as break, but there is a difference. The continue statement is used in loop control structure when you need to jump to the next iteration of the loop immediately. It can be used with while, for, or if else conditions. It won't break the thing, but it will continue. It will omit the statement, omit the current execution, and start a new execution. The Java continue statement is used to continue the loop. It continues the current flow of the program and skips the remaining code at the specified condition. Suppose you have three conditions A, B, and C inside a loop, and you want to execute only A and B conditions. If certain event occur, you can place A and B inside a if statement and then write a continue. When this condition is matched, A and B will be executed and C would not be executed, and the loop continuation will be done. In that case, you can use this continue statement. You can also use it in inner loop, where inner loop continues only. So here we have a continue statement within the if statement. So it will omit this println but continue the loop. It won't break the loop, just the current execution, current case. Omit the next conditions of the loop. So here is the continue statement. In a for loop, we have different statements. Let's say do this, do this, do this. Different conditions can be system out, println, and all such things. Then we have if condition, and after the if condition, we have the continue. We have two conditions before if and two conditions after if. In a normal execution, when if condition is not matched, all the four conditions will be executed, statement will be performed, and a loop will be continued until the termination process has been done. When a condition is matched of the if condition, the continue will run and it will not execute the coming two statements. Do this Only two will be executed that are written above if statement, and it will move out of this condition if the condition is true. So this was a brief introduction about break and continue. Try building a node solution. We can use a break and continue to add more control to our control statements, be it if else later, nested if, while, do while, for, and more. Switch case. You can try implementing your own solution. Use these two tools. They are very useful in developing basic as well as advanced program. We are going to learn more in the coming videos. Till then, keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn about Java arrays. Arrays are a very important component of Java programming. There could be any range of use, be it mathematical use, computational, or simple facilitation of strings or different set of things. Array is simple data type consisting of elements of similar data type in a fixed value of range. So we can create multiple arrays, use it for addition, subtraction, reverse order fetching, anything. You can have different set of numbers, arrange it in descending order, in ascending order. You can have a list of elements. In real life scenarios, we have to deal with a large set of data. In order to deal with such a deep or large number of sets, we need to arrange it and a method mechanism to perform various operations on them. We have character array, integer array, float array, and different set of arrays. So you can use anything. So it is a very important topic and we need to understand it very well. So array is an object which contains elements of similar data types that we know. It is a data structure where we store similar elements. So element need to be similar. In a single array which is being defined as integer, we cannot store a character value. So here we have a same data type. We can store only a fixed set of elements. If we have defined the size initially, we can store only element up to that size. If we have defined the size to be 100, we can define 100 elements, 99 elements, 0 elements, 7 elements, anything between the range. But we could not store 101. And we can also leave it for the size. It may define on its own. Array in Java is index based. We have to fetch data based on different indexes or index number. The index number generally starts with the zero symbol, zero. Normally we do indexing with one, but here we have zero. If we have 10 elements, say, the index number for first element would be zero, and the last element or 10th element will be 9. So remember this thing. So here in the red color, we have defined an array with array named as A of the type integer consisting of 4 elements 33, 3, 4, and 5 in the sequence. An array is denoted with a square bracket opening and closing, and you have to remain it empty. If you do not want to define the values of array initially, you can just write the size of the array between those brackets. So here is the visualization of one-dimensional array. We can have multi-dimensional array, leave it to the future. Currently, we are going to learn here the one-dimensional array. So here is an array which has 6 elements. It will have 6 different indexes for corresponding to each element, and imagine it as a box. In the memory of the computer, if you have been gone through the hardware or different components, data is stored with a key value pair. Here we have the data which is stored called as value or the array element, and it is stored at a location, memory location called as array indexes. It will any element would be fetched based on the index, not on the value. So we need to remember this thing, and there must be a pattern of such things. So it is a continuous, fixed, similar data type storage of elements or values. So it is one dimensional, consisting of 6 elements. If we want to fetch the third element, we can fetch the storage value, reference value, or array index for the third element. We will get the value. So here is a visualization of this thing. We have to define the main, void main, public static void main. Then we need to define the array. Here we have array called A, which is an array of type integer. When we need to write a new array, we need to define it with a new word, keyword. And we have to define its size. So we have defined the size as being 6. Then we need to define the values. We can also define the value in this way. And the first element, 0 is the index value. 1, 2, 3, 4, 5. So it will store 6 values. And we have assigned different values to the different memory location. We don't need to write it in sequence. We can write it in jumble order as well because they are being stored in different locations. And if we overwrite the same value, the latest value will be, or recent value would get the preference. Say if we define the zeroth value as 10, and then again we write the zeroth value as 11. So the most recent value or the last written would be given preference. So here we have to display it on the screen. So we need to use the loop, for loop. Here we are using uh, starting from the index 0, and we don't need know the size theoretically. So we can also find it with a function called length. It is an array function. We can find the length of the array using a dot length, array name dot length. So it will execute till the array has been completed. And system out println, it will display array element on the screen. We provide the ith value, so it will change over time. First it will print the first element, second element, and third element. Then there is a mechanism to pass array to methods in Java. We have learned to define arrays in a method, main method. Here it is, and we can pass the same array and use it in different functions in the program. So what is the method of writing this thing? Just move towards a lower section of the code. Here we have public static void main, and here we have defined an array called A with 4 values, and we have passed this array to the function min, min, or minimum. Here in the function method definition, we have created a different array which is being stored here. The value of A has been transferred to the ARR, the same array, and we can perform various operations in that function. So it is simple, not very difficult thing. Just a simple practice, we can use it, and we can use in this way we can use an array defined in the single function in over hundreds or thousands of functions in different programs. So we have learned about a one-dimensional array, and here we need to learn about multi-dimensional arrays and two-dimensional arrays. In one-dimensional array, we have the dimension, the first element is 0, and the last element is n minus 1, and it's the number of elements minus 1, the index of last element. And similarly, in two-dimensional array, we have m cross n number of elements, and similarly, it is a it is in a format of table or matrix in a well-defined manner. Similarly, we may have three-dimensional arrays in the shape of a matrix book, four-dimensional, five-dimensional, and even 20, 50 dimensions, which would be tedious for a processor and hard to imagine or visualize in the human context in the spatial dimension, but they are reality in the computers. In neural networks, we use different kinds of 3D cubes of the array, the three-dimensional arrays, and here we can use multi-dimensional as well. So here is the format of writing multi-dimensional array. Here we are defining two-dimensional array. So we need to provide 2 times square brackets opening and closing, a pair of opening and closing brackets 2 times, define the array name, and we need to supply the size m cross n. Similarly, if you want to create three-dimension, you can write 3 times the pair opening and closing and define the size of the third element as well, third dimension as well. Similarly, you can write 5 dimension, 10 dimensions and more. Here we have a matrix or array, two-dimensional array of size 3 cross 5. So we have 3 rows and 5 columns. The rows being indexed as 0, 1 and 2, columns being indexed as 0, 1, 2 and 3, 0, 1, 2, 3 and 4. So we may have different values corresponding to this and we can write it as same. Similarly, we have a code for defining multi-dimensional array, and here it is, the first line. We can define it either in the row wise or in the long cut manner by defining each element. It will be difficult. So we can use a different set of curly braces. A single opening and closing curly brace pair would correspond to a single row. So we have to define the values in the row wise manner. So it will start from for, uh, it will move to the size. Here we have to fetch in the row size, the column size, and we can display it on the screen. Here we take 3 cross 3 matrix or two-dimensional array. So to print it, we need to actually run each loop 3 times. So the inner loop will be executed 9 times and the outer loop will be executed 3 times. For the first row, first column, first row, second column, first row, third column, first row, fourth column, and so on, and will be printed on the screen. Similarly, we can perform various kinds of operations, mathematical operations on various set of arrays, be it two-dimensional, single-dimensional, or more. We can perform all sort of searching, sorting, be it binary search, linear search, bubble sort, or different kind of things on one-dimensional or multi-dimensional arrays. Similarly, we have matrix addition, subtraction, division, and more operations that may seem very complicated, but they are not very complicated to write. So for matrix addition, you need to supply two loops, one outer loop for row and inner loop for column. Similarly, we have a third array where we store the value sum of first and second arrays. For matrix addition, we need to have different arrays, be it two or three arrays, four arrays, five arrays that you want to add. Store it in the third array. The values of third array would need to be 0 initially, and all arrays must have the same dimension. Say if an array has 3 cross 4 dimension, 3 rows, 4 columns, so then all arrays or matrices being added or subtracted have the same dimension. This is not required to be the case for multiplication or division, and we can perform various such of things. Try writing your own programs and practice it the array more. Array is a vital concept and basic building block for all set of programs. If you want to move ahead with your competitive programming or design a system programs or scientific operations or machine learning or such kind of things, you need to grab this concept and implement it very efficiently, which needs a lot of practice. We are going to learn more in the coming lectures. Till then, keep learning and keep moving ahead. Welcome back, friends. Here in this lecture, we're going to learn more about Java programming. Here we're going to learn about static keyword and this keyword. So let's start. When we are programming a different set of tools or writing certain code offering different functionality, there might be certain scenario where we need a lot of variable declarations. Say we have 100 students or 100 of employee data, we need hundreds of variables. If each employee consists of 5 different kinds of variable, then we may have a total of 500 different variables. It would be difficult for us to declare, remember, as well as difficult to use in the program. So there are certain features or certain values whose value may range for different users. So there might be repetition, and for that reason we need a static block. Static is used in two ways. We cannot alter its value first, and second, it is a single block, so less wastage of memory, efficiency of memory management. So your program may run on less memory, need less requirement of memory, and perform faster. So the static keyword is used in Java for memory management mainly. It can be used with variables, methods, blocks, and nested classes. The static keyword belongs to the class rather than an instance of the class. So it can directly incorporate with class variable rather without using any object. You can directly call static methods without using class objects. The static variables can be used with as a variable such as class variable, method such as class method, static block, and nested class. So with the static keyword usage, we can have static variables. We need to just simply write this keyword static before writing the data type of a variable. So if we want to create a variable called count of the type integer, we need to write static int count. This would be the format. Similarly, we can define different methods in a static format. We have to write a static void foo. Remember one thing, we have a public static void main. That is the main function that we use in every program. So it is also static. That's all because we need it to be created initially by default at first. So it is a static block. We will learn about what is public later. When we have a static block, we can write different set of code and keep it static by just simply writing the static keyword and placing everything else in the curly braces. Then we can also create static inner classes. We can create a static class within another class by simply writing a static keyword before the class keyword itself. Similarly, we can create a static method and interface method. Then we have a static variable, uh, which has been declared with static. As we all know, the value of a variable may change over time, but a static variable is stationary or remain constant over the time. We could not alter its value or change its value. So there is a problem in case we don't have a static variable. I've also given you the example earlier. There are different students or different set of data, and we need to have roll number, name, and such kind of data. And where a repetition occurs, not in all the fields, all number of students, but in certain set of students. In a school, there are teachers, students, and more. So certain things are common between students, certain things are traits are common between teachers. So we may have a static variable for such things, and this field will get only memory only once. So to be more memory efficient, so we have the public static void main or different methods. We have the static, we have the signature, we have the return type, and different things here. It could be incorporated with different tools. For static blocks, which is used to initialize the static data member, it is actually executed before the main method at the time of class loading. So if we have the main method, a public static void main that we have in every program, and we have a static block, the static block will be executed first. Whether we write it earlier or later, doesn't matter. So if we have println statement in the static block and the main block, the static block will execute first. Then we have this keyword, which is a reference variable, which is used to refer to the current object. It can be used to refer current class or instance variable. It can be used to invoke or initialize different class constructor. This keyword is used in with also variables because there might be different set of variables. Uh, when our program gets very complex, we may have a huge range of methods, classes, and functions. Then there might be the repetition of name of variable. Suppose we have a variable called sum, sum, which is an addition of different variables. The sum variable maybe there might be two different or three different variables with the same name sum in different methods and classes. So when we want to print a method, a value of sum of the class method from different function or method, how we can do so? We can call this by the this keyword. Actually, when we write any variable name and print it, the local value get preference in case of conflict. But if we don't want to print a local value, what we can do? We can use this method. So let's learn this about the diagram. Here we have program, we have a class, now we have a variable declared in the class, we have the main block, we have different method. So with the method, we have the same variable, and in the class we have the same variable. The name of the variable is variable and the values differ. When we want to print the value of the class variable, we can write this dot variable. It will print the value of class variable, which will be displayed as 5 here. And if we want to print a local variable, we just simply need to write the variable name. If we just write this dot variable name, it will print the value of class variable. So it is a simple use of this keyword. There are various uses of this keyword in Java. It can be used to refer instance variable of current class that we have used. It can be used to invoke or initiate current class instructors. Similarly, we can use constructor in place of variable. Just simply we need to write dot this dot constructor name and provide a function opening and closing brackets. It can be passed as an argument to the method call. It can be passed as an argument to constructor call as well. It can be used to return to current class instance and more. We can leverage the power of this keyword and a static block which will empower our usage over different variables and commands. We're going to learn more in the coming lectures. Till then, keep learning and keep moving ahead. Hi there, welcome to the practical session for Java programming. Here we will learn by writing and compiling code to gain hands-on experience in Java. We will begin with a simple program. We will be defining different classes and defining main method, and in main method we will be writing the functions and everything related to programming language. You could write this code on your own PC and save it with a .java file format, and you could execute in the either in an IDE like NetBeans, Eclipse, and more, or you can execute it directly if your computer has a JDK already installed on your system. You could compile from the command line interface if you are on Windows. If you are on Linux, you could run in the terminal. As I'm using the online compiler, you could use online compiler from any system, both a Windows, Linux, and it will be executed in the same manner. I'm using the coding ground, and here you can use. So just simply try to write your own simple program. Just begin by writing the public class method, class name, public class. Here we are defining a class name called first X for first experiment or first exercise. It will be followed using the camel case character. The first character is capital and the first character of next word would be capital. Then we need to write public static void main in the main function, a string args arguments, and provided in the parenthesis, write everything else. This is the main block. It will be executed whenever you try to execute this command, this code. The main method will call other methods or classes when required. Here we declare three different variables of type integer a, b, and c, where a and b have a predefined values 2 and 3 here, and c does not have a predefined value. Then we are going to display a message on the screen, welcome on board. We have to enclose it in double quotes in order to display it on the screen. System.out.println would be the format of writing this thing. We can store result of any arithmetic logical operations in a different variables. Here we can perform addition. We are adding the values of a and b and storing the result in the third variable c. Similarly, you could perform subtraction, multiplication, division, and more operations. Then, after we have stored the value, we would like to display it on the screen. Hit the execute button and it will be executed on the screen. So it will be writing the same command automatically when you're writing on the Windows command line or Linux terminal. You need to write this code Java C, execute the file name, then you write it Java, and the message is displayed on the screen. We can perform different operations like changing the name of the variable. We can also define multiple variables on the same line. We don't need to define it each time. We simply need to add a comma delimiter here and separate the values here. Similarly, we could perform subtraction, division, or more operations. When we want to display multiple arguments using println statement, we need to differentiate them or separate them using a plus delimiter. The plus would not print the sum here, but rather would display the values of values two times. When we write c plus 2 in the c plus c on the println statement, it will display the value of c two times. We want to place a space, we need to add a space in the print statement. If we omit this print ln line, it will be displayed on the same line. Actually, when we write the println, a new line will be added after a string is displayed on the screen. So we need to remove the ln statement on the first string in order to have all the string in the same line. So it works. If you want to display a message on the same line, you could use the print statement rather than using println. The println would be more helpful and more space efficient. What happens when we don't write public in the class method? So it will be unable to call this value. So if it is in a public domain, it is visible to the compiler. So we need to write the class name as a public, the main class. Not every class needs to be public. It is executed. Then we can change the data type here. We could change from integer to double to char to float or more. So the value result of resultant is changed to dot zero because it will be decimal values if we write double or float. Similarly, if we change the value of to the float of the variable and the resultant is still in integer, it could not be stored because float is of 4 bytes and integer is of 2 bytes. So we could not store 4-byte data into 2 bytes. However, we can do the reverse. So we need to make both of them either float or integer. The resultant variable c must be in a higher order variable data type. And it is displayed on the screen. The message is displaying as well. Welcome back. Here in this exercise, we're going to write a simple program to demonstrate the implementation of if-else conditional statement. So let's start. If-else allows us to write different types of conditions in a program and we can implement it with Java. So we are using Coding Ground Online Compiler and we need to first define the main class. Either you are using an custom IDE like NetBeans, Eclipse, or more, you could be writing the same program here. So the program would be the same. You just need to provide a main statement as public static void main in the format within the class name, which will be displayed and executed first on the compiler. The main method is first that is being called by the compiler. We have created an argument or variable called number, which has value 4. It has return type of integer, and then we have the if statement as here. We have checked the value, whether the value of number is greater than 0 in the if statement. If it is greater than 0, the condition followed within the braces of if would be executed on the screen. So the system out to println number is positive will be displayed when the value of number goes greater than 0. Otherwise, the else statement would be called, and else may have different set of values. So we don't need to define the condition for else. It is automatically called when if goes wrong. When the condition of if is being satisfied, the if block is executed, and when the condition of if goes incorrect or wrong in a certain case, the else condition is else block is being executed. And when we are outside the block, all this statement will be followed as normal in the sequential manner, one by one, as they appear on the program. So then we have the system out println statement. This statement is always executed after the if and else block. So it will be executed every time. But as a value of a variable is 4, which is greater than 0, the if block is being executed, which has the satisfied condition. So the number is positive would be displayed on the screen. Similarly, we could write arithmetic operations, perform anything. Like if a value is greater than 0, we could add 1 to the value, or else we can reduce the value from 1. Similarly, we could perform a huge range of logic we're going to learn in the coming exercises. Hi, welcome back friend. Here in this practical exercise, we're going to write a program in Java to demonstrate a if-else later. If-else later allows us to write different set of conditions, and based on those certain conditions, we can execute different section of code. With if-else, we can define only one condition, and that if that condition goes wrong, the else block would be executed. But there are different scenarios where we need different conditions. There could be more than 2 conditions, 4 conditions, 8 conditions, and we can write different if blocks, or rather else if block, to define those conditions. And when all the conditions goes wrong, we have the else block. So here we start writing our program. We need to first write a public class main method, provide the name of the class, provide the main method for it, a public static void main, string gs, and then we need to write everything within this main block. We can define a variable. So here we have a variable called number and assign it a value 0. It is of the type integer. Then we have the first condition or the if block. Within the if condition, we can define the first condition. So let us define the first condition as when the value of number is greater than 0, a set of condition arguments or keywords would be executed. So here we want to display a message on the screen. So we can write system out println the number is positive because the value is greater than 0. Then we may have a second condition which is written as else if. Then we can have a value. So here the condition is when the value of number is smaller than 0. We would be interested in displaying a message a number is negative. Similarly, we could write more conditions if we need uh, right away by using else if statement. We need to write else if more and more time. So here we have only 2 conditions, and the third condition is when the first two conditions get false. Then we have the else block, system out println. It will be displayed as a number is 0. When the value is greater than 0, it will be displayed as positive. When it is smaller than 0, negative, and otherwise 0. We have an error here, the syntax error. We need to write the proper name of the variable. So you can fix it or rectify your error by seeing the compiler output. So here the message is displaying as a number is 0. It is the correct output because the value is 0 here. Similarly, we could have more conditions in case we want to write percentage, 10%, 20% or more. We can change set of variables and write else if statement multiple times based on different conditions. We could have a 4 condition, 8 condition, 100 conditions, 1000 conditions and more. That way it is called a ladder. We could climb up the ladder any time we want, any number of times. We could use the if-else conditional statement either in the nesting form or more. Now we are going to learn more in the coming exercises. Hi, welcome back. Here in this exercise, we are going to write a program in Java to demonstrate nested if conditional statements where we would compute largest among three variables. So let's start. We just simply need to declare a class, make it public, is public class, provided class name. Then we have to simply write public static void main as we also do always do this statement. After that, we could write any variable or logic in that there. We are interested in defining three different variables having different set of values. You could have any return type, be it integer, float, double, a long, or more. Let's make it double. We have three variables as n1, n2, and n3. Provide value for n1, let's say negative 1. Then we can have different values. So for n2, we have 4.6. For n3, we may have another value like minus 2.3. And let's define another variable to compute the largest value. And we will store the largest value here in this variable, the largest. Then we need to write a if statement. And the nested if statement, we define an if-else condition within another if-else. So the first condition given in the parent if, the root outer if to be called as better, where we compare the value of n1 and n2. If the first variable is greater than or equals to second variable, then it will go inside of the if statement and execute another if, where we are interested in finding the value between n1 and n3. If the outer if has been executed, we already know that n1 is greater than n2. So that we can compare value of n1 to n3. If n1 is greater than n3, then the largest value is n1. Otherwise, n3 is the largest. This is a simple logic. Similarly, if n2 is greater than n1, we can have different set of scenarios. We can have else statement, else if statement. In the else statement, we have n2 greater than equals to 3. Then we have the largest value equals to n2. And if this not goes wrong right way, then the largest value is n3. So this is the simple logic. We have defined two if-else conditions within if-else condition, two different. This is a nesting operation. Similarly, we can also nest if-else ladder in an if-else ladder in a systematic manner. It may be complicated, it may look complicated in the first hand, but it is an arranged, properly arranged logic. Then we can at last display this largest value on the screen after executing each of the if-else statement. So here it is showing an error. Error could be different thing. I could troubleshoot that thing based on the message. Here the largest value is being displayed as 4.6 or N2. So here we have displayed it on the screen. The largest value could be assigned with the equation symbol, and here we can simply calculate. In a different scenario, if you might be in a complex situation, willing to calculate marks of different students or different percentages, you would be requiring nesting if or if as ladder. So you could combine those things. If you have a large set of conditions, the if else ladder and nested if, the combination of both would be very helpful for you. Alternatively, we could use switch case statement in the same manner that we are going to learn in next exercise. Hi, welcome back. Here in this practical exercise, we are going to write a program to demonstrate switch case conditional statements where we would compute and display name of the day of the week like Sunday, Monday, Tuesday based on their sequence number provided. So let's start with switch case. It is similar to if else. We could implement both nested if and if else ladder with switch case. So just simply start writing the code. We need to provide everything within the class. So we need to first write a public class, provide a class name, then the public static void main, a main method, string args. Then we can write, declare different variables, assigning them values, and so on. So let's start by declaring a variable called week and assign it a value. Here we have the value as 3. It is a type of integer. Take another variable called string consisting of a day, which is a day. Then have a switch statement. With switch case, we need to write a switching a variable. We need to provide a value of a variable, and based on that value, different cases are executed. Case 1, day equals to Sunday. Then write break. When we write, similarly, we can write multiple cases. The case 1, case 2, case 3 denotes that value of week. If value of week equals to 1, then case 1 would be executed. Otherwise, when value of a week is 2, the case 2 will be executed. Indentation could be followed, but it is not required in Java. There are different languages like Python, which more work on indentation rather than just syntax. With Java, you could write anywhere. Indentation helps decorate your code to increase the understandability. Similarly, we have multiple cases, case 1, 2, 3. Say if we have a value of a week as 7, 8, 9, 10, then the case would be 7, 8, 9, 10. It is not necessary to write the first condition as case 1. Case A, case B could be also there in case of a value of a string or character values. The break statement is written just to get out of the loop conditional statement when we have a value of a variable that we are switching here week, and when the value of week is 1, say, the first statement will be executed, and after it is executed, the break would be called. The break will move control out of this conditions outside the switch case section. Similarly, if the first case does not satisfy the condition, the second case would be checked. If it satisfies, it will also move out of the loop if you provide the break statement. Similarly, if second is false, then third, fourth, fifth, and so on. And when all the conditions get false, we have the default segment, which is similar to else in the if-else ladder. Different cases are denoted that else if and if statements, and then we can have. Here we are providing the value. Uh, we have the day of the week as value, and we have the corresponding value. The first day of the week is Sunday, second is Monday, third is Tuesday, fourth is Wednesday, fifth is Thursday, sixth is Friday, and seventh is Saturday. So we can print based on different values. We can also take input from the user as well that we are going to perform later. It will be computed as similar. The default statement will help you provide condition when all other conditions get false. And outside this segment, we could display the value and system out println. The day is and the value of the day. Sunday, Monday, Tuesday, and so on. So it is executing. The third day of the week is Tuesday, so it will be displaying uh, Tuesday. We can change the value, and the sixth day is Friday. Similarly, we can check more different values as well. Let's make it 1, then it will be displayed as Sunday. We can also take a value from the user or from any input file. We can also always take input from web also. You could also design web applications right away from this. The switch case could be used. A large number of cases could be supported in the switch case. You could write entire program here. The nesting of switch case would be as you can write another switch case statement within a case of a switch case. In the case 1, say, you can have uh, another switch and so on. It will be more tedious, but you can use it as an alternative to if-else ladder or nested if. Hi, welcome back friend. Here in this practical exercise, we are going to write one more program on if-else ladder to increase our command over conditional statements. Here we would compute whether a given number is 2-digit, 3-digit, or 4-digit number. So let's start with this. We need to first write a class name, declare the class, public class and class name. Then simply the main method, public static void main string args. Then within this parenthesis, we can define everything else. We already know how we can write if-else ladder. But here we have one more example and we have different cases that could be used. We can use a different set of operations, arithmetic numbers as well. We have defined a number called having value 1, 2, 3, 4, 1234. We can use a greater than, smaller than, ampersand, and different symbols. Here we would be interested in comparing values. And if both conditions get satisfied, we would be executing those things. We are checking in the first condition if whether the value of number is smaller than 100 and value of number greater than equals to 1. So we need both conditions to be true in order to execute this if statement. If value of number is greater than equals to 1 or is smaller than 100, the first block would be executed and it would display on the screen that it is a 2-digit number from 1 to 99. Then we have else if statement, which would check if the value of condition number is smaller than 1000 and greater than equals to 100. So from any value from 101 to 999, the second block is executed, which will display that it is a 3-digit number. Similarly, we could perform more things. If we replace ampersand symbol with or, then either of the condition need to be true, not both of them simultaneously. Similarly, we have different cases as well we could write. So this is the use of if-else statement. We could have more flexibility and more options on this. with a vital practice and writing different set of rules. There's no single computer program, a complex or real life program that is never written without using if else, for, while, and such things. So it is fundamental and used in all the levels. Similarly, we could check for four-digit numbers as well. So it may have a value ranging from 1000 to 9999. The four digit would be displayed as here. And then we can have an else block which would display that it is neither of the two, three, or four digit or anything else. Number is not between range of 1 and 10,000, 9999. That's four digit. Similarly, we could also perform more operations as well. So when we execute this code, it will display that it is a four digit number because 1234 is a four digit number. We could also replace this parenthesis in each section. It will also start working the same as it was done. The parenthesis is required when you write multiple line of codes in any code block. For if we have only single line of code here, the system out println it is a two-digit number. Say if we have multiple lines within if, so how the compiler would know that we all of them is related to if. In for that case, we need parentheses. Parentheses is good for identification to increase code readability and understandability. Because in real life scenario, you would be working with multiple developers on the same program. So all need to be having a better understanding of the program. You can write more logical implementations with if-else. Try building your own solution. We will be learning more in the coming exercises. Hi, welcome back friend. Here in this practical exercise, we're going to write a simple program to demonstrate for loop, where we would find sum of a range of values without adding each addition as a separate line of code, but just once within the loop structure. So let's start. Loop is used to perform repeated execution of the same statement over and over again based on different set. We could increment, we could add, we could subtract, we could perform various kind of operations. So the method of writing it will be simple. We need to declare a class and public static void main method, and then we can declare variables and could use in the for statement. We have created a variable called sum equals to 1 having a value 1 sorry 0 of type integer. Then we can declare for statement for loop. It has three different parameters: the initial condition, the termination condition, and the increment or decrement. The initial condition would set the value from the initial value. So for I, which is a variable, we have the initially defined it as 0. It will continue till the value of I remains less than 1000. And in each step, it will perform increment of 1, I++. And it will execute a single line of code, sum plus equals to I. That means sum equals to sum plus I. It will be executed multiple times. And final statement that will display the result on the screen as some variable, the system out println. Here, when we have a variable I declared as 0, sum equals to 0. So it will add numbers from 0 till 9999. So this program would display you the output of the sum of all the numbers from 1 to 999. So the output is here is 499500. You could check it, otherwise it will increment each time and the loop will continue. We can use while loop in place of for different conditions. We have do while loop, we have while loop, and for is a better alternative when we want to execute certain thing within a range. We also have a for each loop, which we are going to learn in the coming exercises. And for loop could be used in a nested, in a ladder, or any other form, like if else and switch case. Hi, welcome back. Here in this practical exercise, we are going to write a simple program to demonstrate a for each loop, where we would take an array and access each array element without using initial and termination condition of for loop. So let's start. We just simply need to write the class statement as public class main and provide the public static void main function. Then we start writing the syntax for each. We would be requiring a set of elements or values in the array. We need to write a declare an array providing values. Then we can use a for each loop. Just write a character variable. So here we have a variable called vowels having return type character. We could make it array by simply passing the values. Say the vowels are A, B, C, D. Sorry, not A, E, I, O, U. A, E, I, O, U. We can define the array by providing values in parentheses separated by commas written within quotes. Then we need to write a for statement here. We could perform the same operations that we could do with for loop, simple loop, with for each loop if the value is followed in the array. So here we use the function called vowels.length. Vowels is the name of the array, and dot length would find the length of the array. So here we have 5 elements, so the length is 5, and we continue our loop till the value of I remains less than 5. So it will be executed from 0 to 4 element. That means 5 times it will be executed, and the system out println vowels I would be called 5 times. So all the values of vowels will be displayed on the screen based on the value I. So the first value 0 would be displayed, second, third, fourth, and fifth. In the same way, we have the for each loop where we need to simply define a variable. Here we have a variable called item of the return type character and place a colon, double colon, double dot, hit the execute button here. Uh, with the item value, which will execute each element of the vowels and display it on the screen. Here we have certain errors that could be displayed, and you could go through that line where the error is indicated. You could solve that error or try using the import.java.asterisk library. Asterisk means all the libraries packages are imported. That is not error. The error is we have forgotten to write the square bracket symbol in place of vowels where we have declared it to be error. We could use that thing to rectify the error. And that's it. It will be executed. So here we have A, E, I, O, U, the vowels displayed on the screen 2 times because we have first written with a simple for loop, then with a for each loop. Both works to display the same output, but works differently. In the for each loop, each variable is called one by one. And here we can provide this anything in the comment section, and here only the for each loop is being executed. It will access each element of bubble array by item and will be storing that value in the item variable, and it will display each value one by one on the screen. Similarly, we can check both the conditions. It will display the same output on the screen. A for each is benefit in different cases. We don't need to provide the termination condition, initial condition, and repeatedly perform increment or decrementing. When we have to access all the elements of an array or some elements of the array, we could use this for each. It is vital and reduce the lines of code and increase the program readability and understandability. We're going to learn more things in the coming exercises. Till then, keep learning and keep moving ahead. Hi, welcome back, friend. Here in this practical exercise, we're going to learn about how we can take input values from a user using a scanner class. Here we would take values for radius from a user and calculate area of the circle based on that input. So let's start. In the beginning of the program, we need to just write a statement for importing a scanner class value. Now just write import java.util.scanner. It will import all the library, functions, methods, constructors of the scanner class. The scanner class allows us to take input from the user very easily. Then we need to define the class name, public, make it public class, say area of a circle. Then we need to define the main block, public static void main string arguments. We can simply write the scanner method. We have to create an object for the scanner class. Just write the name of the class, that is scanner s, which is an object equals to new scanner, and provide a system.in as a value for scanner constructor. Then write system.out.println to display a web message on the screen. Enter radius of a circle to the user so that user may provide input for the radius of the circle, and we can calculate based on a formula. It can work for any value user provide for the radius. Then the format of taking input, it would be double return type, which is return type. R is a new variable equals to s dot next double. S is the scanner object, which will allow you to take the input from the user. It will take the input in the format of decimal values, a numeric format, and it will be taken from the user. Then we need to define another variable called area and provide a formula for calculating the area, which would be pi r square, or 22 into r by 7. Simply. We could also multiply with 3.14 if we don't need the exact value. Then we could display that area on the screen by writing the system.out.println area of the circle equals to area. So there are different errors based on different sets, multiple errors being displayed, but actually there is a one error, that is we have not written the main method. Write public static void main. System string args and provide everything within the parentheses. So it will be executed as there. I'll just hit the execute button. This is displaying the output. There is still an error. So we need to provide a radius of the circle. Now we are using an online compiler, so we need to provide the value in the format of stdin, standard input. If you are using the IDE or command line utility, you will be asked to enter a value. So we have provided the value radius as 4, and it is calculating the area of the circle as 50.2857. My mistake over here, area is written as area of triangle, but actually it is area of circle. Similarly, we could calculate area or parameter or any kind of things by taking simple input from the user. We could change the values as well. The formula writing of formula is simple, declaring of values. Similarly, for next to double, which is a method that allows you to take value in the format of double from the user using scanner class, we have next line, next char, and other methods as well to take different characters or different lines from the user. Hi, welcome back. Here in this practical exercise, we're going to learn about how we can take input values from a user. Here we would take multiple inputs from the user and calculate area of a triangle based on provided values. So let's start. We just need to write a scanner class. We need to import a scanner class by simply writing import java.util.scanner. After that, we could start with a class method. We have to declare a public class area of triangle. Then we need to write the main method, a public static void main. We need to declare the class as public in order to access this class. And everything goes within the main block. A scanner is used to take input from the user. The input could be in varied format. It could be a character, a string of characters, integer, decimal, float, or multiple values. We need to first create an object for the scanner class by using the syntax scanner s equals to new scanner, where scanner is the name of the class, here scanner, and s is the object for this scanner class. Here, when we want to access multiple values from the user, we could create multiple objects for the scanner class. To display a message on a screen to allow user to know whether he has to provide the value or not, we could write a statement on the screen. Enter the base of a triangle. A triangle has a base, hypotenuse, and a perpendicular length. So we can calculate the area when we know the base and the height and the perpendicular length. We could take this value and assign it in another variable. Here we have declared b as a double variable, and we could read the input using s.nextDouble using this method. Then we could ask a user to provide the value for height or perpendicular length using the system out println statement, and read the input as the same manner and store it in another variable. So h for height. We could call the next to double to access the value in the double format or float decimal value. Then we could perform the calculation based on certain logic. Here we need to calculate the area of a triangle. So we will multiply base into height and divide it by 2. Base into height divided by 2. The product of base and height and divide by 2 would be the formula for calculating area. After we have calculated the area and stored it in another variable, here area, We could display it on the screen by writing system out println statement, providing the area of the triangle value on the screen. We could write area of a triangle and provide this argument or value. We need to provide a value in format of standard input. If you are using online compiler, we could provide multiple values separated by either enter or spacebar. Or when you are using IDE or command line utility, you would be required to provide the values whenever they are asked. And when you execute, it will be executed as here. Here we have a simple error. We have omitted a parenthesis, and here it is. We have provided base and height of a triangle, and the area of triangle is computed as 10. 4 and 5 was the value for base and height, and based on the formula, it has calculated the area of the triangle. Similarly, we could take multiple streams of input from the user using multiple objects for the scanner class or multiple parameters. We could read an entire line, entire page, a character one by one, based on different formats or double, float, integer, and more. Hi, welcome back. Here in this practical exercise, we are going to write a program to demonstrate usage of mathematical functions using math class. Here we would calculate the distance between two given points on the coordinates x and y. So let's start. We will take values of two variables and compute the distance between them. We need to first write the import java.lang.math to access the math library and all the methods and values of functions in that. Then we need to define the class, the public class and the class name. For that, here we are going to take 2 points. Each point would have two values, x and y. For that, we have four different variables, x1, x2, y1 and y2. x1 and y1 correspond to the values of uh, point A on x and y planes, and we have x2 and y2 as x and y coordinates, value of x and y coordinate. So just write the values. Here we have all the variables in the integer format. You can take double, float, long as you wish. Then we have the distance between them. We will be calculating that thing, and for that we have a variable called distance of return type double. We can assign values to different variables anytime we want. We could also assign variables at the point of declaration, or you can also perform later on. Here we have assigned a value 2 to x1, 4 to x2, 2 for y1, and 4 for y2. Then we need to call the mathematical method or method for the class maths. We are using the method square root sqrt to find the square root of a value given in the brackets. We have x2 minus x1 into x2 minus x1. That means x2 minus x1 square plus y2 minus y1 square, whole in the under root, and store that value in the distance. That way we can have the distance. It is a distance formula that we have read in the elementary level at our school, class 10th or any level that we read. The distance formula. Similarly, we could perform a wide set of mathematical operations. Here we can display the value of this distance that we have taken on the screen using system out println, a distance between 2 points and the distance variable. It will display the distance between those 2 points. Here we have written this distance variable. Hit the execute button to provide the output. Here we have the value 2.8284. This is the distance between these 2 points. We have written a double, so it will be displaying the value in double. If we reduce it to float, the output is showing certain error. It is lossy conversion. We have loss of a value. We need to make both the variables as double here. Similarly, we could perform a wide set of mathematical operations like finding cosines, sines, trigonometric operations, logarithmic functions, integration, differentiation, and wide set of operations, entire calculus, and advanced mathematics as well. If you are using for scientific calculations or building calculator, simple calculator, or performing accounting software, the calculation of simple interest, compound interest, or entire GDP of a country. You could write a program for each of them. Hi, welcome back friend. Here in this practical exercise, we are going to write a program to calculate factorial of a given number. We would be using for loop in this case. So let's start. A factorial of a number, say a factorial of a 7, would be the multiplication of all the values from 7 to 1. So it will be resultant as 7 into 6, product of 7, 6, 5, 4, 3, 2, 1. It will be displayed on the screen when we need to perform factorial. So there are different ways to calculate a factorial of a number. One simple method is by using loop. You could use for loop, while loop, or another loop. You need to simply provide a class, declare a main method, take a variable, say n, having a value 5 of type integer, and then we have another variable called fact having value 1. Then we could write the for loop condition having the value I equals to 1 here in this case as a starting initial condition. Then we could check if whether I is smaller than equals to n, and then provide the increment condition I plus plus. Then we could write fact equals to fact into I. Factorial is equal to factorial into the I. This way we could display the value on the screen. When the first time the loop is executed, it will set the value of factorial fact as 1 and n as 5. The first time the value of fact is multiplied with 1, so it will have the value 1. The next time it will be multiplied with 2, so it will have the value 2. And third time 2 will be multiplied with 3, and so on. We can change the value of n anytime and it would display the value of factorial for that number. You could find the value of 10, value of 6, value of 3, any number, natural number. Similarly, we could perform more mathematical or complex operations simply by writing, understanding the pattern and making it simple with if, for, another loops. Hi, welcome back friend. Here in this practical exercise, we're going to write a program for array having multiple values, and we will be calculating average of these values. So let's start. We could perform any kind of mathematical operations on array, including addition, subtraction, multiplication, division, and more, and we can calculate a percentage, average, and other values as well. Just we need to write just simply public class and provide a class name here, calc average. Public class name, write the main method, public static void main string args, and then we can define the variables and declare the array as well. Here we have a variable called n, which has a value 5 of type integer, and res for result of value 0. And we declare an array in the format as a is the name of array, provide a pair of square brackets, and just write int a equals to new int 5. 5 is the size of this integer array, and it consists of 5 elements. The first element being 0, first, second, third, fourth. These are the 5 elements. We start with index 0 and end with an index n minus 1, n being the size of array. So here we can declare explicitly the values of each element by directly accessing those indexes, like a of 1 equals to 20. 20 is the value for second element of array. Similarly, we can have a of 2 having value 30. So these are the 5 values for 5 different elements of array. Let us write a for loop here with initial conditions I equals to 0 until I remains less than n. We have to perform I plus plus after each step, increment of 1. And here we have a code just to modify the value of result. Here we provide a formula for the summation of all the elements. Result is equal to result plus array of I. It will store the sum of all the elements. And it is simple to find the average, average being the sum of all the values divided by number of elements. So we can display the average of each array element. Just write result divided by n. Let us execute this thing. So by executing, we have the average of these 5 elements. Similarly, we can have a even larger number of elements, and we can change things like here. Here if we define n equals to 4, we can change the value from I is smaller than equals to n. It changes the average because it is being computed for the more elements. Similarly, we can perform different changes. We can also declare array values uh, using parentheses or read from the user input as well. And we can also read using loops. Whenever you use arrays throughout the program, use square brackets to access the array elements. And loop would be a better solution to increment one by one each value each time. Hi, welcome back. Here in this practical exercise, we are going to write an accounting program for businesses where we could calculate the amount needed to be paid for a certain discount rate for a product. We could similarly perform wide range of operations or accounting operations like getting profit and loss and different percentages for the business. Here we are just simply interested in finding the discount rate. So let us, we need to declare the class and the main method, and then we can continue our work. We have created different variables here: discount, dis for discount, amt amount for amount, mark price for mark price, s for sum, uh, and declare them as double return time. Let us initialize the mark price with 1000 and discount with 25. So it will be discount percentage, and we could display a message on the screen for our users. So simply we need to write system out println mark price is equals to a print element mark price. It will display the value of mark price, maximum retail price. And we could offer a discount to a user. We could also take input from the users as well, but here based on what product they are purchasing, a list of product that could be pressed. Here we are displaying another message that discount rate is, that is discount percentage. A 25% discount is offered for a product here. We could use a different formula here for finding discount. S equals to 100 minus discount, and amount equals to S into mark price divided by 100. It will display the amount the user need to be paid. And we can print a message by writing system out println amount after discount that a customer needs to pay. Just provide the value of amount here simply on the screen. Let us execute this code. There are certain errors, spelling mistake, and mark price. Here mark price and market price is small and capital S. The issues are. You can go through the errors if they are different errors. No one can write error-free code, but after practice, you could uh, troubleshoot different set of errors. So here it is. The mark price is 1000, discount rate is 25%, and amount after discount to be paid by the customer is 750 rupees or US dollar or any unit, whatever you want to pay. Similarly, we could calculate a wide set of things: profit, loss, tax, income tax, sales tax, or such things that could be calculated. High-end accounting or business softwares are developed this way. They can be consisting of different variables, arrays, loops, certain formulas. You can also use mathematical functions as well based on your requirement. Hi, welcome back friend. Here in this practical exercise, we would be learning about string operations. Here we would read and input a string from a user, perform certain operations on that string, and display the reversal of the string. So let's start. We have to write the public class, provide a class name, then write the main method. We would be requiring a scanner class in order to get the input. So we have to import the scanner class library. We need to write import java.util.scanner on the top of the program. We can change the name of the class anytime we want, but that name must be the same as a file name. Whatever is the class name here, rev, R-E-V, then we have to store the file as rev.java. Then we can write by declaring the class object for reversal. We can create object of the same class that we are in or any other class from the main method. We have to simply write the class name followed by the name of the object equals to new class name. And we have to create an object for a scanner class. In order to take input from the user, we have to create a scanner class here. S is an object for a scanner. We have to write scanner S equals to new scanner system.in. It would take allow us to take input from the user. When we want to print a message on the screen, say enter a string, so that a user may start providing a string, we have to write system.out.println, enter the string. Then we could create a string variable here str in order to take string. Remember here we are using next line. So we have to write str equals to s dot next line. Next line, it will read a line from the user or string of words. Then we could also print a message on the screen. The reversal of a string is as here. First, we have taken the input from the user and input string, read it by using a next line method of the scanner class and stored it in a variable called str using the scanner object s. Then we could display the reversal of the string on to the user, where we have written r.reverse provided str object. Reverse would be user-defined method that we are going to create here, and we would be having it access using the class object because the method is being created within this class outside the main block. So this is the method way to call this method. The main block is the first method to be executed when a program runs, and then we can call or reference any other block, be it a method, constructor, another class, or different things, or even different libraries. We could access any method from a class using objects. Here we have created the method reverse of type string and made it static so that the values don't change. We have provided a string here s, which is the same string that we have read from the user and stored it with str. Remember, we are passing str in the reverse method from the system out println in that thing. And here this string get stored in s. This is not object for a scanner. This is a string variable here. We have created an empty string with r denoted by open and close quotes without any character in between. We have a for loop here and provided the length of the string. It will start from the end j equals to s dot length, the length of the string, the last element, and will be reversed in order to until it reaches the first element. We have decremented each element, and then we have provided a formula to calculate this reversal of a string. We have stored in a variable r, which is a string variable, where r is incremented with s dot char at j minus 1. This is the formula. And whenever we have calculated this thing, we could return back using the return r keyword. It will be reflected back to the calling method where it is being called and it will be executed. There are certain error may be occurring on the screen. Although we have written the enter a string here, we have not provided the input in the standard input here. The online compiler we need to provide the input. Here, this is, we have provided a string and reverse of the string is that. Let's provide a space between those two messages so that it would be more readable. India was our string and AIDNI reversal of this string. Similarly, we could provide any other output like world, WORLD, and the reversal of this string is DLROW. That's it. So we have successfully read a string, created a method outside the main block, created an object, called it, provided a formula to calculate the reversal, stored in a third variable, and returned it to the main calling method and displayed on the screen. Similarly, you could perform any range of string operations with concatenation. You could perform any kind of operations like you can read an input text and replace a variable, say, uh, replace A with R whenever it occurs. You have to read character by character. Here we have taken the complete line as it. Although you could use next char, double, and more of functions that you could use. You could concatenate multiple strings and remove empty spaces or convert capital case to small to capital and such things. Any kind of string-based operations could be performed using string methods, and taking an input using a scanner is not a difficult thing. It's simple. You can also take array and perform string methods on array as well. You could store each character as an element of an array, and huge range of things are being done. All the encryption kind of development tools or softwares are being developed using performing the strings. Any kind of hashes that are generated that are string methods, or functionally you could create your own cryptographic tools as well. So this is a route for such wide range of opportunities waiting for you. We're going to learn more in the coming lectures. Keep learning and keep moving ahead. Hi there, welcome back, friends. In the coming series of lectures, we're going to learn about object-oriented programming in Java. And here in this lecture, we're going to learn basic concepts and what is object-oriented programming approach. So let's start. The basic object-oriented concepts include a wide range of tools. We have class, object, polymorphism, encapsulation, inheritance, abstraction, modulation, and more. We have overloading and such concepts. We are going to learn about these things and try to implement these things with writing a code. So let's start. In the programming languages, before the emergence of object-oriented, we have the procedural approach, a procedural programming approach or procedural-oriented programming, where we have global data, local data, in form of variables or other things. We have different methods or functions, and they interact with each other in that way. There is less code reusability. The codes are generally very complex, and it is hard to realize and implement. With object-oriented programming, we have certain things in mind. First of all, we get the code reusability, such that the data and functions or methods get used and reused again and again in different formats. We have different layers of visibility mode or protection for data. We have the public, private, and protected mode, which was missing in the earlier example. All variables will be either public or open or hidden completely. But here we follow hierarchy. There we have a hierarchical traits that are being implemented from different approach. Uh, the languages like C is completely procedural or language. Language like C++ is partially procedural and partially object-oriented. Java is completely object-oriented, and more things. There are different languages, programming languages out there that you can classify into categories. Object-oriented are getting highlighted these days, and a typical example of procedural and object-oriented, apart from the programming world, we can get if you say you would need a furniture table in your for your home. In the procedural approach, you would first of all sow the seed on the ground, wait for the plant to grow, become a tree, then you will cut down the tree, drag your timber or wood into planks. You would create the nails and hammer the nails together to form the table. That's why you have to work from the stage 1 to stage end, and you have to wait a lot of time. You have to do a lot of work on your own. So when we have to create a new program, we cannot use the various functionalities of existing programs. We have to write it again and again. But with object-oriented approach, we have to simply go to the market, ask the plank, ask the hammer, and just get it done very easily. So the task is being divided into different persons or different developers. And different developers working on the same project may divide different components of the software into different categories. One person will design UI, one will design the back-end logic, one will design the security modules, and such on. And you can use the traits that are being developed, the formats of GUI, the security implementation in form of components that will be used again and again in the coming ways. It will be production model and it will be implemented in the industrial scale. So object-oriented could be also said as an industrial revolution to the procedural mechanism. So let us understand what is a class and how a class is being implemented. From the day one when you are learned about Java programming and seen the first Java code, you have seen the class very well. You have the syntax called class and you have been introduced to the class that everything in Java is a part of a class. Every method or thing you write in a form of class. There are classes and you compile those classes and run the output. So what is a class? Class is a category, simply categorization of components, and we want to divide those things. So just imagine we have a jungle and in a jungle there are huge range of animals. So we can have two different classes, plants and animals. The plant class will consist of different categories of plants, which will be divided further into different classes or even objects. Similarly, we have animal class, and in animal class we have different objects. A giraffe may be an object of animal class, a dog may be an object of animal class, an elephant may be an object of animal class, a lion may be an object of animal class. So an object is a component or an instance of animal. Object, in other words, is also called as an instance of the class. So an instance is a particular entity which is a part of a class. So keep this thing in mind. Then we have nesting of classes. You have seen nesting of if-else, nesting of for loops. Similarly, we have nesting of classes. Nesting is different here. Uh, we have particular traits or specialization to be called as nesting. Generalization is class. Uh, if we want to generalize things, we move in the top level, and if we want to specialize things, we move downwards. A vehicle is a generalized form of all kinds of transportations available there. Then we may categorize it to the wheeled or unwheeled vehicles. Then we can classify it to four-wheelers or two-wheelers. Then four-wheelers could be classified as further as cars, trucks, and more things, as specific models, as specific companies, and a specific person's car for a specific unit. These all are classes or components, or you could divide these things. When you are a car driver, you are interested only to know the tools that you can incorporate. You would be interested in understanding the concept of gears, how you can use the gear, what speed will be provided, acceleration you could perform on different number of gears. You would learn about brakes, handbrake, emergency brakes, steering wheels, and such things. You are not interested whether the car has two-stroke engine or four-stroke engine or an electric vehicle. You would not be interested in learning the final details of the internal combustion engine. So this is abstraction. You only know what you need. You don't need to learn everything. So this is a modulation or abstraction that is a feature of object-oriented approach. So there's few more differences between procedural approach and object-oriented approach. The procedural approach is a top-down design. The object-oriented approach is focused on objects rather than design. We can move or down anytime we want. The procedural approach has limited code reuse. There, it could be reused, but with very limited uh, conditions. With object-oriented program, you can use the complete program, a complete method, a complete set of variables, complete structure, complete class, or different things. You could use things more and more over and over again in the form of overloading and different things. With procedural approach, the code gets complex when you try to build a huge solution. But with object-oriented, the solution would not be having a complex code rather than a complex design or implementation. You need to understand how things are being integrated. You have to build the small things and integrate it in a very fashion manner. With the procedural approach, the focus is on global data, and with object-oriented, we have focus on protected and public-private data. The public-private and protected data concept is similar. I will tell you in inheritance. There's are classes and instances. We know a class could be classified as a generalized entity having the same behavior of different instances. So there could be 10 top 10 buildings called skyscrapers, and the building would be an underlying class. There would be different instances, say Burj Khalifa or Taipei 101 Tower, Empire State Building, such are the instances of building class. Similarly, we have more classes and more buildings. Then we have encapsulation as a very important category of. We have learned about the car. A car driver does not know how the car is being implemented, actually, but just he knew how to drive the car, how to fix errors. So encapsulation is keeping different methods, objects, and variables that are not uh, required to be learned by outsider. It will be encapsulated or hidden inside the capsule. You could see only the outer covering. You could not see the finer details. So such data which falls under the category of hidden, they will be called as private. And protected data are those who are between private and public. Public data are available to everyone. They can access or use that things visible. It is visible to everyone. You have to explicitly um, tell those things. The protected data is only visible to the same class, the holder of variable class, and the directly direct child of that class, anyone who's inheriting. So what is a child class? Here we have the concept of inheritance. Uh, Suppose your grandfather has certain treasure hunt in your home. He used to hide certain treasure, and he has a key for that treasure. He does not want anyone outside his home, other than his son, daughters, and granddaughters, grandsons. He do not want it to be known to anyone else. So he will provide the key to your father and you over and over time. So this will be protected kind of data. But anything that is personal, deep hidden for his own privacy, such thing is not available to you or either your father, available only to him. And things that are in a public domain, like his speech or books that may be written by him, is available in the public domain. That is called public. Similarly, we have more things. Here, there's a difference between procedural and object-oriented in the manner that we implement things. Suppose we have a generalized function for different shapes. In the procedural approach, we have to define each component in a single function. But with object-oriented, we can design a function once and modify its behavior in different classes. We have defined a rotate and place on say functions once, and we have changed the property over and over again for different kind of shapes like triangle, circle, and square. Similarly, we can directly call or access the different functionalities of different classes. Here we have two classes, stack and queue, having different implementations of data structure. We are going to learn later. With the main function, we can call the objects of such classes and access different things and perform various functions. Here we have created the object as the name of the class are stack and queue. Remember this thing. In the main method, the top method, we have created an object called capital Q for the class Q and the object for stack as capital S that you can see above. It is the format of declaring objects of a class. Then we can access the methods and objects or variables directly of those classes using the objects of the same class. By writing this command s.add, we can call the add method of the stack class. In the object-oriented program, we have different classes and different variables. They consist of many well-encapsulated objects and interact with each other by sending different set of messages that may be either tokens or different set of things. We can perform wide range of operations with object-oriented programming. We are going to learn more in the coming lectures. Till then, keep learning and keep moving ahead. Welcome back, friends. We are learning object-oriented programming with Java, and here in this lecture, we are going to start our journey with a class and object. So let's start. We all know that there are different objects referring to the same class. We can create multiple objects for the same class that are also called as instances based on different cases or uses. A Java object is a self-contained component which consists of different methods and properties of the same class to make certain type of data useful. It has a specific value. A class system allows a program to define various new classes that are also called as derived classes in terms of an existing class, superclass. Base class could be there, and we can create multiple derived classes by using a technique called inheritance, and we have overriding and augmenting as well. There are different objects referring to different classes. Uh, we have multiple instances of same class, and each object could be used for different set of purposes. Uh, let's understand here with an example. We have a class called student, which have two different variables, one of type integer and another of type string. Then we have the main function, and within the main function, we have created the object of this class using the new keyword. The object is called as s1, and we have s1.id and s1.name to refer the variables of this class. We can display the values on the screen. We have class objects. We have class called animal and multiple objects referring to the same class. The objects could be visualized as different species of animals. We have lion, we have tiger, we have elephant, we have birds, we have dogs, wolf, giraffe, deers, and more. This is an example. Here we have a class called dog, which consists of different variables or parameters and different methods. A dog may have four different variables called breed, size, age, and color that define a species or particular dog and distinguish one dog from another. Similarly, a dog may have different set of methods or functions called as eat, sleep, sit, and run. So we can create different objects. Here we have three different objects which can have different values assigned to different variables. And based on that variable, we can perform various methods of operations. To say the breed is Napoleon Mastiff and the size is large, age is 5 years, and color is black. This is an object. Similarly, we can have a breed called Xiao Xiao, size is medium, age is 3 years, color is brown. So we have the same parameters defined in a class, and we have specialized or specific method assigned to the instances or objects. The difference between class and object is very fine. We don't need to confuse here. An object has a state in which all the properties have the values that you either explicitly define or that are defined by default settings. It could be defined or based on users. Uh, it is a difference between the class and object that shows where is a tendency we want to use them interchangeably of the context. There are different ways to create an object in the Java. We can use a new keyword that we used earlier in the example. We can also use the new instance method to create an object of the class. We can use the clone method also to create objects. We can use deserialization, and we can have factory method being implemented to create objects. All of these are not important. We can get perfection over certain things. Simple would be most useful. We can also create object or instances of the class outside another class. In earlier example, we have the main method placed rightfully inside the class, where we are interested in creating the object. We can create object outside the class. The student class is different, and we have different class, trial student, which has no relation with that class, but both are part of the same program or same file. We can create that thing. There are generally three ways to initialize an object. We have created an object and now we want to initialize or assign value to different variables using the object of the class. We can use a reference variable, we can have a method, we can use by a constructor. We can assign values based on these three mechanisms. First is initialization through the reference. We can initialize an object variable of the class by means of objects by storing data directly into the variable objects. In the class, we have two variables, say ID and name of integer and string types. We have different class, and we can create object of the same class, and we can assign value by using a reference. We have object called S1 of the student class. We can assign value to ID, say 101 if you want to assign a number. We can assign it by referencing object S1 dot name of the variable. That's way. Similarly, we can assign the name as anything, any string you want to assign. This is the first mechanism. Then we have different methods. Say we can initialize a value through methods. If a class have different methods, we can operate on various methods. The method may get or take input based on different variables. Here we have two variables of type integer and name. We can pass uh, values directly to this method. The format of writing this would be the object name s1 dot a method of the class and pass the variables directly within the braces separated by comma or any delimiter. Then the third method is to initialize using the constructor. It would be similar to using the method. There could be multiple constructor or multiple methods of the same class. So there are different objects. An object that may be referring to different set of libraries, and the object class is referring to Boolean, character, class, math, runtime, number, string, system, thread, and throwable different classes. So we can perform various operations, and we have to learn the different hierarchical things, models that are being there. The class objects could be denoted here. It could be used with all kind of variables, data types, and methods in the class. The object methods of the class object class are different that we can use. We can use finalize, we can use a close that creates the copy of the object. If you want to create a multiple object having the same set of values of the variables, we can create a clone of existing object. We can have a hash code to create suitable for putting the object into hash collection, which is a data structure. We can perform various tools for concurrency and locks, implementing of locks and file handling. We can have notify all, wait. That is a function of threads class. We are going to learn later. We can convert the text representation of the object to string using the toString method. Similarly, we have different classes. If we have the name of object and we want to learn about the class, we can use this method getClass, where we can get information about object's type or class. Similarly, we can use the finalize method to call for garbage collection. That is the end of stuffs. So we are going to learn more in the coming lectures. Till then, keep learning and keep moving ahead. Welcome back, friends. Now, in this lecture, we are going to learn about polymorphism, which means one name, many form. There might be different functions or methods out there in the programs with the common name, the same name, but they may have different functionality. This is called polymorphism. We can implement polymorphism in object-oriented programming approach, which could not be done in traditional approach. We can create a overloading of methods, constructors, and different things. So let's start. Here we have method overloading, which is an implementation of polymorphism. If a class has a multiple methods having same name but different in parameters, they differ in number of parameters, properties of parameters, or more things, which is called as method overloading. We can implement method overloading in two ways in Java. First, by changing number of arguments. If the initial method have two arguments, we can implement by changing the number of arguments, like say 3 or 0 or 1, anything. They may not have the same number of arguments. Or the second method is by changing the data type. If the first method has a data type integer, we can change the second method with a float or double to have support of same numerical values. So we are going to learn each one of them in detail. Here is an example of method overloading and the case without method overloading. Here are two programs. On the left hand side in the orange color, we have a program of implementation of three methods without method overloading. They perform the same operation of addition of variables and return the sum to the user. For that reason, we have created three different functions or methods: add 2, add 3, add 4. All have different names but perform the same operation. They only differ in the number of variables as input but perform the same result. But with overloading, we can have the same name, method name, for performing different operations. Only the properties differ. So if a user provided any input, he may enter two numbers, three numbers, or four numbers. We do not know. We could not define it at earlier in the development time. So we need to call all three functions, three methods, and pass the user input value to all the three. And if any one matches, we can get the result. So it would be more tedious or memory intensive task. With method overloading, we only need to provide only single method. It will take the desired operations. It will pass to the desired or destined method and it will compute the result easily. So we only need to write single name once. We don't need to write three methods. Similarly, if our program scales up, this would be very useful. The overloading would be useful in cases we want to perform various operations and we do not know which method to call exactly. And also, if we are working in a development environment, working with a team, we also need to have a lot of methods with the same name uh, to avoid errors or compile time errors or different sort of errors. We can have overloading in our hand. Then there is a constructor overloading. Constructor is an instance of class with the same name as the class name. It does not have any return type as it is at default. And we can create overloading of constructor as well. We may have different variables. It may differ with a zero parameter constructor, one parameter, two parameter, multiple parameter. It may have a copy parameter storing address of another variable or the data constructor. So how we can implement overloading? The first method is changing number of arguments. We have a class here called adder, which have two methods. Both are static int type. The return type is integer. The name of method is same, add, and perform the operations. The only difference between those methods is the number of arguments that we have. We can create another class, define the public static void main method, and we can call those methods using the object of the previous class, or directly we can directly call using the class name. Similarly, we can also implement overloading by changing the data type. In the initial method, it is being stored in the integer format, and the preceding method, the same name, is implemented using different data types, say double, float, or more. So it will automatically identify which method to call. If the data provided by the user is in format of integer, the integer method will be called, and if so, it will be provided as float or double value, decimal placed value, it will be passed to the double method. So this was about a method overloading. We can implement use solutions with method overloading and constructor overloading. Overloading is an important topic when you're trying to create different set of classes or implement polymorphism in the advanced programs. Try implementing your own solution. Till then, keep learning and keep moving ahead. Welcome back, friends. We are learning polymorphism, and in the previous lecture, we have learned about method overloading. And now, here in this lecture, we're going to learn about method overriding and the difference between two. So, let's start. So, what is a method overriding? Uh, Method overriding is present in between the child and the parent class. If a subclass or child class has the same method as declared in the parent class, is known as method overriding. The method name of the parent and the child class must be the same. Variables may or may not be declared in the parent class, or they may have been declared, redeclared, or new definition has been added in the child class. It is called overriding. If a subclass provides the specific implementation of the method that has been declared in the parent class, is also called overriding. Uh, there could be specific parameters or generalized parameters in the parent class, and the specialization of those parameters is governed by child class. So we here in example we have two child class, manager and clerk, both inherit from the class employee. Employee is a base class or parent class. Manager and clerk are child or derived classes. All three methods have the same. All three classes have the same method called salary, and the salary method in the employee class or the base class has some limited definition or declaration of variables. But the method of salary in manager has different functions of manager function, and in the clerk it has different function. They will have specified features. As we all know, all employees have a salary, but manager have different salary and clerk has different salary. So it could be incorporated as a so. So there are certain rules we need to follow when we are trying to implement a method overriding in Java. If a subclass or child class has the same method as declared in the parent class, the method must have the same name as the parent class. That's why it is called overriding. The method must have the same parameter as in the parent class. If it does not have the same parameter or same set of parameters of the same data type, it it would be called as overloading rather than overriding. There must be an is-a relationship. That means inheritance, child, parent, or hereditary inheritance. So here is an example of method overriding. We have a base class called vehicle, which has a method called run. It has a different implementation. It currently displays a message on the screen, vehicle is running. Similarly, we have another class called bike 2 that extends or inherit features of vehicle class. So it has the same name method and without any return type as the parent class. It has different message displayed on the screen. So when we create an object for the child class, bike class, it will display the run method of the child class. We have the overriding of the same method as the parent class. So it is supported here and we can do so. We do not need to declare everything from scratch. Certain features can be inherited directly. So we have learned about overloading and overriding. So what is the difference between two? With the overloading, we have different methods with the same name, but with different number of parameters or either different return types. With overriding, we have the same method with same name without any difference, but we add certain things or remove certain things. We add specification in the child classes. Uh, Overloading, where more methods share the same name, it occurs during compile time. Overloading actually is performed using the compile time, and overriding occurs during the runtime. So here is an example of overloading and overriding. We have already learned about these things. And we have different objects that are being implemented using different methods. With overriding, we have different classes following different set of rules, and we have different methods with the same name, same return type, and same number of variables. Whereas in overloading, we have same method with same name, but different number of variables or either different data types or return type. So this was about method overriding. Try building an OR solution. Overriding and overloading both would be very efficient and useful in creating general programs. Try implementing your own solution. Till then, keep learning and keep moving ahead. Welcome back, friends. We have been learning inheritance, and now here in this lecture, we are going to learn about final method, final keyword. When we have a base class and a derived class, and we have different methods, variables, or constructors in the parent class that we do not want to alter or modify from any base class or different methods, even in the same class. We want to define it once and for all. We do not want to change this definition or value. So how we can implement such things? We can add a keyword called final before the declaration of such variables and methods. So let's start with final. A final keyword can be used to restrict a user. It can be used in various contexts with variable, method, and class. A final keyword can be applied to different set of values, and a final keyword, a final variable that has no value, can be called as blank final value, which can be only initialized with a constructor. So here is a scenario where we can use in different cases. First case is a final variable cannot be modified. We have a class called A. We have a final value variable called a small a of type integer. And we have also declared B as a final variable. So we cannot change the value or modify the value anytime in the future once it's declared. Then we have a base class called A and a derived class called B. If a class A is declared as final, it cannot be extended or inherited. Similarly, we have a final method which cannot be overridden. However, it can be called or executed from the base class, from the child class as well as base class. We cannot change the value. We cannot redeclare the method. So here is a final variable. Uh, this is a program where we have declared a variable called a speed limit equals to 90 as a final variable. So when it is declared as final, we cannot change the value in either of the cases. We cannot change anywhere and the value will remain the same. Similarly, we have final method. This declaration could not be changed. We have a method called run, which is declared as final in the base class bike. When a child class inherits from the base, the definition could not be changed, and when we call that function, it will execute the base method only. Similarly, we may have a final class that could not be inherited at all. With declaration, if we even write the extents, it won't work anyway. So this was about keyword final that we can use during inheritance to have better control over the inheritance. Keywords such as super, this, final allows us better control over different set of languages. So try building an OR solution, write your own programs, and implement various solutions. Until then, keep learning and keep moving ahead. Welcome back, friends. We are learning object-oriented programming with Java, and here in this lecture, we're going to learn one of the key concepts that is called inheritance. So let's start. Theoretically, inheritance is a method by which a child class or derived class can inherit or reuse the methods and fields of a parent class. It is a simple hierarchical model that we use between the classes to derive different objects and offer various functionalities. A child may inherit different features and functionalities by either modifying, adding certain things, or removing certain features from the parent class. There is a typical example here. There could be classes regarding shapes. So the shape class would be parent of all the classes. Triangle could be derived from the shape. Quadrilateral could be similarly derived from the shape. Right angle triangle is a kind of triangle which is a child class of triangle class. Similarly, rectangle is a child of quadrilateral and square is a child of rectangle. So this is a hierarchy and this hierarchy is followed by inheritance. When we move up to a level or generalization or towards the parent class or base class, it is called cast up of inheritance. And when we move downward, it is a specialization or moving to the derived or child class. So here our parent class shape has two different methods called draw and erase, which has certain generalized features or specifications or simply a variable definition or declaration. With each derived or child class, like circle, square, and triangle, we have the same function, same method inherited with little modifications regarding behavior of different child classes. So here is an example of inheritance, how it has been done. So we have a base class called employee having certain features, and we have a derived or child class called coder. The format of writing this inheritance is as we need to use the keyword extends, extends. So we need to first write the name of the child class. Here is coder is a child class which extends from employee class. Employee is the base class. So this is the format of writing this thing. And rest everything goes fine. Here we have created an object called C for the coder class, and we can access The variables or different methods of the employee as well as coder class using the same object. An object from child could be used to access public or protected variables of the base class. So here are types of inheritance that could be found in different programming languages. We have a single inheritance when there is a single superclass and single derived class. We have hierarchical inheritance when there is one parent and multiple child inheriting from the same single parent. We have multi-level inheritance where an inheritance in the form of grandmother, mother, and daughter. We have three generations or more generations, each one inheriting from the preceding generation. Then we have hybrid inheritance, a combination of single hierarchical and multi-level inheritances. Then we have a multiple inheritance where there could be multiple base class or superclasses, which may be not possible in Java these days. Well, however, it is supported by languages like C++ and more. To avoid various conflicts, we don't support multiple inheritance. So how we can write a single inheritance? This is a program for single inheritance. Here we have an animal class. We have the dog class, which is a derived from animal. So this is a simple format of writing single inheritance. We need to write extends keyword once. Then we have multi-level inheritance, where we have one base class which has a derived class, and this derived class is the base class of another derived class. Animal class is the parent of dog class, and dog class is parent of baby dog class. So this is we can create objects of different things. And similarly, we have hierarchical inheritance where we have two child classes and one base class, parent class. Multiple inheritance is not supported in Java to avoid simple conflicts. Suppose there's two parent classes and both parent class has a common child class or derived class. Both parent class have the same method with same name but with different definition, and the child class object calls a method of a parent class. So there is a confusion or ambiguity regarding which method of which class has been called. So that's for the reason Java does not support multiple inheritance. However, you can use the features of multiple classes using multi-level inheritance. So this is about inheritance. We can use inheritance to draw big scenarios. We can build different kind of solutions using inheritance. It is a powerful tool, and we can perform inheritance between different programs and different files. Try building your solution. Till then, keep learning and keep moving ahead. Welcome back, friends. Previously, we have learned about inheritance in Java, and when we inherit from different base classes or parent classes, there we face certain situations where we have a method with same name in the child and the parent class as well. So how we can define which method or variable we are actually interested in using? We can use a specific keyword called super in that case to resolve conflicts. And we are going to learn about this thing in detail here in this lecture. So let's start. A super keyword is used in Java as a reference variable which can be used to refer immediate parent of a class object. Immediate parent class, we have multiple parents in a multi-level inheritance, and the super keyword would point to direct or immediate parent, just father or mother of the child class, not grandparents. Whenever you create an instance of the subclass, an instance of the parent class is created implicitly, which is referred by super reference variable directly. It is accessed by writing the keyword super separated by dot, and then you can use the variable name or the method name. Here we have the class parent, we have the child extends the parents, and we both have the same variable called name of the type string, and we can point to the string a name method of the parent class using the super keyword. Super.name would print a parent. We can assign value. So super can be used in different scenarios. Super can be used to refer to immediate parent class instance variable. Super can be used to invoke immediate parent class method. Super can be used to invoke immediate parent class constructor. It can be used in case of variable, method, and constructor. We have a class written in Java, and we can convert using a compiler it into the class file. When the class file gets completed, we have to use a super method in order to access a super variable and define those things. It gets executed as a first statement. We have the immediate parent class that can be accessed from the instance. Suppose we have an animal class, we have the dog class. Dog class is a child class of animal class, and both have the same variable called color of type string. When we want to print the color of a dog class, the child class, we simply write a color. But if we want to print the value of a color variable of the base class or the animal class, we have to write a super dot color. This would print the value of color in the base class. Similarly, we can use for methods and different variables. We can invoke immediate parent class methods using the super keyword as well. When we have both when we have same method name eat here in child and parent classes, we can access the method from the base from the child class to the parent class using the super keyword. The super dot eat braces would run the eat method in the base class. Similarly, we can invoke immediate parent class constructor by just simply writing super followed by braces. We can write this keyword and initiate the constructor of the superclass. So this was about variable super. Super can be used in wide range of cases, and when you are using inheritance, you can use super to directly access the immediate parent methods, constructors, and variables. Try building a node solution. Till then, keep learning and keep moving ahead. Hi, welcome back. Here in this practical exercise, we would be learning object-oriented programming by writing a custom class, by defining values, different methods, and access them from main method in the main class by using objects, and perform various operations by making function calls. So let's start with this. With object-oriented programming approach, we have more flexibility over our program or commands. We have to first declare a public class. Would be the custom class. Here we have a lamp class. We have a variable called boolean or is on for return type boolean. Boolean stores either true or false value for a variable. Here we create a method called turn on of return type void because it does not return any value. It just changes the value of a variable is on equals to true. So when turn on method is called, it will change the value of is on variable to true. Similarly, we may have a turn off method which may change the value of is on variable to false. It is simple denotion of a switch, electrical switch of our bulb that we can say. We have a third method called display status, which will display the current status of this switch, either turned on or off based on its value, and will be displaying a message on the screen. We have to write system.out.println to display this message on the screen. Light on, off, and provide the value of the variable is on. It will display true or false. And now let us create the main class from where we have to create a main method that would call the methods in the class lamp. Here we have the main class as example main. You can also create two different files for both different classes, but you have to compile it to classes file. The first is a lamp file and second is the main file. Or you can always write in the same method, same program. Here we create an object for the lamp class in the main method. Lamp L1 equals to new lamp. It will create a new object called L1 for lamp class, allowing us to access its method or variables to the object. Similarly, we can also create multiple objects for the same class. We have two different objects, L1 and L2, for the lamp class. Now we have to call this method for L1 object. Let us change its value to on and by calling the method turn on, and then change the status of L2 object to turn off, and then we can display the first instance by writing L1 display status and L2 the display status. So what happens after we do this? We can check by hitting the execute button or by pressing Ctrl F9 in case you are using an IDE. There is a simple error is showing up. It will be fixed. What is public static void public class? Now the name of the file must be main example, and we have to make another class as not public. So it's showing up. In the first method, first instance, it changed the value to on, so it is displaying the light is on true, and the second status has changed the value to off, so it is showing the display status false. The error was that we could not make the earlier class as a custom class as public. The public class must be the main class here in this IDE. However, in your program, you could make both the classes as public, or you could create a separate files. Similarly, we could access multiple methods by creating multiple instances. It is useful in cases of real life cases. Whenever you request a server application or a website, you hit particular request and the program is written only once. However, multiple instances for different users called sessions are being created based on the different objects that are created on the run. It could be correlated here with the concept of objects or instances. You could create a wide number of instances and both or each instance has separate set of data or values and perform operations differently based on same concept. We can have different methods being called from different classes using different objects and show the result here. You could use all kind of variables, be it a boolean, integer, float, character, string, or anything else. You can have also return type. Here we have used void return type for each method. You could have integer, float, and return the value directly to the screen. No need of having the display status being called. We will directly display the message. Hi, welcome back. Here in this practical exercise, we would be learning inheritance, which is one of the key concepts of object-oriented programming. We would be creating three different classes where child classes would inherit from parent classes, both having different methods. We would be calling methods from main class using objects. The child method may have a varied copy of the parent objects. Just write import java.iutil dot asterisk. It will import all the libraries and methods of the util library. Then we need to write a java.lang.asterisk. It will import all the language libraries. Similarly, we could have java.io.asterisk for importing input-output methods. We could write these things or omit that thing. Some compilers already import those useful libraries. But for separate things like the scanner or different classes, you have to include, like servlet and work. Here we create a first class that is a parent class called alpha. It has a method called display alpha of return type void. It displays a message on the screen system.out.println. Provide any message that you want to display. Because it's a method of alpha, we will be interested in printing a simply alpha. Similarly, we could create a different class called beta here, which would inherit alpha. So we need to write extends keyword in order to inherit. We need to create a class which is a child class which extends the parent. So here alpha is parent. We need to write alpha after the extends keyword. So it will beta is a child class, alpha is a parent class here. We have another method in the child, display beta of the same return type void. Make it public so that it could be accessible from outside this domain. Let us write a system.out.println in order to display a simple message on the screen. Just provide a custom message. Here we want to display beta because it's a method of beta. Then we can create a main class, provide a class name, make it public, class, provide a class name, here main, provide a main block, public static void main string args. Then we can create objects of different classes, both child and parent. Or if we want to access the parent, we could also access it using the object of the child, because child has inherited certain traits of the parent. Beta b equals to new beta. It will be creating an object for beta class or child class. Here. We have called the display method of alpha for using the object of child. You could do so because the method is being made public. It could be also called if the method was being made protected, so that only inherited persons could call, inherited class could call. If it was private, it could not be called from the child class. Let us execute this concept. So it is displaying the correct message on the screen. Method of parent class is accessible through object of child class. This shows the inheritance is complete and we could incorporate inheritance. Inheritance is useful in different cases. All Java library methods are inherited from one or the other classes. We don't use all of them directly. We don't need to directly write each logic in each program. We could inherit traits from or methods from an existing class. We could use the features which will reduce the lines of code in our program and reduce the time or effort required to write a program. Inheritance is a useful concept. We can use this thing. There are different types of inheritance, multiple inheritance, multi-level inheritance, hybrid inheritance, and such more inheritances that we could use. Try building your own solution. Hi, welcome back. Here in this practical exercise, we will be learning Method overriding, which is one of the key concepts of object-oriented programming. We would create constructors, class methods, and calling methods of parent class from that of child class. So let's start with this. We have to first import certain libraries, say java.lang, java.util, java.io in the beginning that you can use. Then we can create the classes, make it public void, public class, parent, have a constructor. To create a constructor of a class, we have to just write the name of the class for which we have to create a constructor without having any return type or visibility mode like public, private, and protected. We have to place a open and close brackets. It is similar to method, but is not method. Constructors are called when we create an instance or object of the class. Here the constructor would display a message on the screen, constructor of parent, and display method void display would display a message like parent method on the screen. So whenever we create an instance for this class, the constructor would be called. The constructor could be of different types, the copy constructor, parameterized constructor. Parameterized constructor could have different arguments. Copy constructor would have address of another constructor or another variable. Here we have a child class which extends the parent or inherits the parent. It may also have a constructor. It may have a method as well. Here we create a constructor for child with the child open and close braces. We provide a simple system.out.println message on the screen. Here we write a constructor of child. Then we can create a display message here for this child class. Void display. It may have a message or certain functionality that could be performed. Then we have system.out.println child method. After we are done with this, we are just going to create a main method or main class from where we could access these things. Here we use this super variable. Super is used to call the method of the superclass or parent class. The super.display would call a display method of the parent class. Let's create a main method, main block, public static void main, string args. We could create object for this class, parent or child class. We're just creating object of the child class. With the child object, we could directly access the parent object as well. Parent methods, parent constructors are accessible from the child. This is the power of inheritance. Here we have called the display method of the child class, and it will automatically call this method for superclass as well. Just execute this code. There's a certain error. Missing semicolon. Not a big deal. Just provide a semicolon. It will be executed as well. Here, constructor of parent is called first because it was executed, and constructor of child is executed whenever we create a class. Then when create an object, the child method is called first because it is inside a display message of the child, and when we call the super.display, it will access the display message of the parent or display method. It will display the method. We know the constructor is called whenever class instance is being created. When we created the object of the child, it automatically called the parent, and thus the parent was constructor of parent was created first or executed first on the screen. We never directly called the constructor here, but however the constructor has been executed whenever we create the object. When we don't create the object, the constructor is never executed. So we need to have this thing. We can always explicitly call the constructors as well by passing the arguments of variables to the constructors, or they can also return the values as well. Hi, welcome back. Here in this practical exercise, we would be learning instance of keyword that help us identify relationship between classes and objects. So let's start. Here we need to just write a class here. Let us create a class animal, provide a parenthesis, and we can create a class of different traits. We have a class mammal that extends animal class. Mammal is a child or subset of animal. Similarly, we could create different methods, constructors, or arguments in each class. Then we can create another class as well. Say public class cat that extends mammal. This is the main class here because we have made it public. Now let us create a public static void main, the main block, and create objects of those classes, animal, mammal, and cat. And with the objects, we could identify whether any object is an instance of which class. We could check. The instance of object is useful in case when we have a long number of classes and a large number of objects being created and we have a certain confusion and we want to verify it, or for any obvious reason we could use this thing. Here we create a different object for different classes: A for animal, M for mammal class, and here we have an object for this main class, the cat. C equals to new cat. C is the object of the cat class. And when say we have used different methods or different things here in the program and we get confused of which method is for what, which object is belongs to what class, we can check. Here when we print a system or println M instance of animal, it will check whether M is instance of animal or not. Then we can also verify for different things. Say is instance of mammal or not. Actually C is an instance of cat, so it must not be true. And we can write another string, system out println C instance of cat or animal, as you can say. So let us execute this code and check what is being appearing on the screen. It is showing true, true, true. So M is an instance of animal because M is an object for mammal and mammal is a child class of animal. So M can access animal. C is an instance of mammal. Actually C is an object for cat and cat is a child class of mammal. So it is true. And also for animal because it follows multi-level inheritance. So we can verify that thing. If inheritance was not there, it could not be identified as well. Hi, welcome back. Here in this practical exercise, we would be learning multiple keywords and terms. We would be using this super keyword and pass values with object and would associate between two different entities. So let's start with this program. Let us first write the class, declare the class, then have different, we could have different methods or arguments with this class. It could be displayed here. With this super keyword, such things could be called. Here we have the car class having a variable called a car name called string, car ID of type int. We have the constructor car with the same name as the class. It has two different variables, name and ID. It is a parameterized constructor having two different parameters or variables, name and ID here. We could have access, we could pass the value from the constructor to the variables, class variables, using this keyword. This dot car name is the car name variable of the class car. However, a name is the instance or the value that is being passed through the constructor. So we can assign this thing. This is the usage of this keyword. Similarly, we have another class driver that extends from this car class or inherits a car. Here we have a string called driver name. We have a constructor which is also parameterized constructor for the driver class having two different arguments, a name, cname, and a third argument, a cid. We could also create multiple constructors for the same class, each having different number of variables, and that could be zero number of variables, more and more, 2, 4, and anything with different return types. Here we also use another keyword that is super. We could access the super method using the super. For the super class, a cname and cid, we pass the car name and car ID to the super method and access the driver name or pass the value. Now let us create the main class. Create a main method, public static void main, string args, then create an object for the class by just simply writing the class name, here driver, object obj. Object is the object, obj is the object of driver class, and let us pass a different set of values directly from this class name. It will be initiated to the constructor. The values will be passed to the constructor. The driver constructor has three arguments. First is type of integer, second is integer, and third is first is a string, second is a string, and third is integer. So the first two are strings, name and the car name, the person's name and the car name, the Suraj, BMW. Then we have the car ID 2248. It is being passed. Then we call the system out println method. It will display the name of the driver by using the driver name from the object. You could access that thing directly, and the driver name is being called. Similarly, we could access the car ID directly from here. We have to make this main class public, and then we can execute this thing. There are a few errors here. The car ID has not been identified. We have to place a semicolon, I think. here. Semicolon would separate. When we have the same type of return type, we could use this thing. It is running. Suraj is the driver of the car. ID 2248. It is being displayed. Here we have the use the super constructor or super method. Use the this keyword to access the current variable of the class variable, and we can use the object of the child to access the parent class. Try building your own solution. Use these keywords and this super or more when you have the inheritance or object-oriented programming approach. Hi, welcome back. Here in this practical exercise, we would be learning polymorphism, which is one of the key components of object-oriented programming. With polymorphism, we can create multiple methods with same name, but they perform different operations. The same name could be carried for different methods, performing different set of operations, having different number of variables, returning different results, and more than that. So let's start with polymorphism. Let us write the code here. Just need to write the class, provide a class name. Here the overload is the class name. Provide a method. Just write a method name here. A void demo, having an integer a, and displaying a message on the screen. System out println a. It will display the value of a on the screen. Then we can have more methods or more things here that let us have a different method with the same name, demo, having different number of arguments. We can have 0 argument, 1, 2, 3, 4, and more. The first demo method have a single argument, a. Then second demo have 2 arguments. So these are same name but with different behaviors or different functionalities. It is displaying a different message on the screen. It will display value of A and B both on the screen. This is system.out.println A and B, and provide a variable name for that with the plus symbol. Then we can call these methods using object from an external class, the main class. We could also have a delimiter here, like comma, that could be separated in the codes. We have the separation symbol or that is plus used in the system out println method to display a string on the screen. Let us create another method with different return type. Here we have the demo method with a return type double. Earlier we have the return type void. We could change with a number of variables, change in return type, and use the same name. In real life programs, we may have thousands of lines of code. So it would be difficult to have, uh, say, if we have thousands method used, so thousand method may or may not have the unique name always. So we can carry the same name, but have different set of arguments or different functionalities that could be used. So polymorphism is a useful function when a program may scale up anytime. The third demo method displays a message on the screen having the value of a in the double format, and it returns the multiplication of a into a, the square of a, the value. The value in 3 arguments differed based on what value we pass. If you pass an integer, single integer value, it will go to the first method. If we pass 2 different integer values, it will go to the second method. And if we want to provide a single double value, it will be provided to the third demo method. So it depends on the input what we provide. It will decide which method is being executed. We have the main class having a main method, a public static void main string args. Here we can create object for this overload class. Obj is the object, write the class name on the object equals to new class name. Here we create an instance, a variable or result of the type double, and we could be displaying on the screen with this. Let us call the demo method of this overload class and provide it value. We have provided a single integer value 10, so it will be passed to the first method. Here we can also provide multiple values. When we provide two integer values, it will go to the second method having two different integer values a and b, and we can store the result of any variable. So we have called the third with the double value, float value, decimal value, and it has been stored in the result object, result variable, and we can display the message on the screen. System out println output is, and we can have the result being shown on the screen. The third will print a product of 7.6. So the first the line of that is being output on the screen. Uh, Value of first method is being called. My system out println message is 10, a and b are 10 and 20, and the double value of a is 7.6, and the return value of 7.6 or the square of 7.6 is 57.76. We can also return from different methods. An integer value could be returned, but we have used the void return type in the first two cases, first two methods, so it was not returning any value. We can also return the value on the screen. Similarly, we could have a method with characters or string literals. We could have more methods, n number of methods could be called. We could also pass the arrays, a complete file as well. We could integrate these things to build a complete solution. When you're building a complex code for complex application, polymorphism is one of the key things that goes to your mind. So don't need to worry about unique name for each method used in the program. The name could be same, but your behavior or operations may differ. Try building your own solution, keep learning and keep moving ahead.